Yep. Let's start him. What is Spark? First one, when we say Spark, Spark is a big data processing framework. Big data processing framework. So big data means not only Hadoop team, any data, which is huge volumes. So Spark is a big data processing framework. It can process any file system. It can process any file system. It's a big data processing framework. It can process any file system thing. It may be HDFS file system. It may be local file system. It may be local file system. It may be any RDBMS. It may be any NoSQL database. It may be any streaming framework. So it may be S3 file system. So it can process any data thing. It can process any data. Spark does not have storage. Spark does not have storage. Does not have storage team. It is completely processing framework. Spark is a completely processing framework. Spark framework implemented or Spark software implemented using Scala language. Spark framework or Spark software implemented using Scala language. Spark provides API. Spark provides API. API stands for Application Programming Interface. Application Programming Interface. So Spark provides API for different languages team. Different languages like Java, Scala, and it provides API for Python, and it provides API for R language. So by using these any of these 4 languages, we can write Spark application stream. Spark software designed by using Scala language, but API available for Java language, Scala language, Python language. You can develop Spark applications using any of these 4 languages stream. Okay, understand, right? It's a completely processing framework. It can process any file system data. It is not specific to HDFS file system team. It can process any data team. It does not have any storage. It is completely into processing. We can implement Spark applications using any of these 4 languages. It may be Java, it may be Scala, it may be Python, it may be R language. So API available for 4 languages. API means Application Programming Interface. Application Programming Interfaces means predefined classes or functions. So predefined classes or functions available for Java language, Scala language, Python language, and R language. Okay. Now Now let's start understanding differences between Spark and MapReduce team. MapReduce is a big data processing framework. It already available before Spark. MapReduce is a proven technology. It is a fastest processing mechanism or algorithm compared to existed frameworks. It is a parallel processing. Why people are using Spark? What are disadvantages of MapReduce? What are advantages of Spark? Why people are going for Spark as processing? First important difference. MapReduce is a big data processing framework. MapReduce is a big data processing framework. Big data processing framework. We can implement MapReduce using Java or Python, or it supports plenty of languages. Majorly we implement MapReduce using Java or Python. Spark is also a big data processing framework. Big data processing framework. We can implement Spark using Java or Scala. Spark applications we can implement using Java or Scala or Python or R language. So we can implement using only 4 languages. But MapReduce we can implement using multiple languages. Majorly we implement either using Java or Python team. Next important difference, very important difference. MapReduce tightly coupled with HDFS file system team. HDFS file system. Tightly coupled with HDFS file system. It can process only so it can process only HDFS file system. Let me take diagram. So mapper we give input as HDFS file system. Mapper we give input as HDFS file system, and mapper output also HDFS file system type. Mapper input is HDFS file system and mapper output also HDFS file system. So MapReduce has 2 phases. One is mapper phase and other one is reducer phase too. Mapper has 2 phases: mapper phase, reducer phase. For mapper, input is HDFS file system. Mapper input is HDFS file system. It will take HDFS file system as an input. It will process the data and stores results temporarily into local file system thing. It's local file system. Result it stores into local file system. LFS means local file system team. This mapper output become input to reducer. Reducer process the data. Reducer process the data, and finally output it will store into HDFS file system. Output it stores into HDFS file system. So complete MapReduce, input is HDFS file system and output is HDFS file system. It can process only HDFS file system. That's why we are saying MapReduce tightly coupled with HDFS file system. But Spark can process any file system type, any data. Spark can process any data, like it can process local file system, means operating system file system. It can process HDFS file system. It can process S3 file system. S3 file system is a AWS file system. It can process any RDBMS like MySQL, Oracle, DB2, Postgres, etc. Any database team. It can read any database, it can store data into any database. Next one, it can process any NoSQL database. Any NoSQL database like Cassandra, HBase, MongoDB, Couchbase, any NoSQL database type. It can process any streaming framework. It can process any streaming frameworks like Kafka, Flume, Kinesis, etc. Any streaming framework. So it can process any data type. It is not specific to particular database or particular file system type. Anything, it can process anything. That's why people are using Spark as a processing, Hadoop as a storage. Hadoop specialized in storage and processing, but Spark specialized in processing. Spark can process any file system data. And next, very important difference, team. Very important difference. In Hadoop, we have MapReduce. We implement using Java or Python. These are the major languages. Also, it supports plenty of other languages. So writing MapReduce applications is lengthy, time-consuming process. So Hadoop introduced, in Hadoop we have Hadoop frameworks or ecosystems. Hadoop frameworks like Pig, and we have frameworks like Hive. Pig has its own language called Pig Latin, and it is a scripting language. So by using this Pig scripting language, we can write any big data processing logics with very less code, faster development. Anyone can easily write Pig Latin statements. And we have other one, Hive. Hive has SQL. It is like SQL. It is like SQL. So developing first on top of HDFS file system, we can use Hive to expose HDFS file system data in a tabular format. So it works like a warehouse environment. It works like a warehouse environment. We can expose HDFS file system data in a tabular form, rows and columns form. So by using Hive, we can design models, means structure setting. Okay, and here we have a SQL. SQL is almost similar to SQL. So we can write a big data processing using simple query language, SQL, Hive query language. Anyone can easily learn, anyone can easily implement any big data processing. Again, we have other frameworks like Scoop. So this framework can be used to perform two operations, import and export. Importing data from RDBMS to Hadoop, then apply processing. Result we export from Hadoop to RDBMS. So this is the main important purpose of Scoop team. Next one, we have a Flume. Flume is a streaming framework. Streaming framework. Flume is a streaming framework. Okay. So we have other frameworks also. These are the main major components. Similar way, in Spark also, we have different components. First one team, Spark core. First important component, Spark core. Here we write RDD programming team. How we write programs using MapReduce? Similar way, we write RDD programming using Spark core. In Spark core, first one. Second one, Spark SQL. How we have Pig Hive? So how Pig and Hive providing simple SQL kind of queries. Spark SQL provides data frames, data sets, and tables. Here we write programming called DSL, domain specific language, It is object oriented approach, or we use native SQL, means SQL team. Native SQL means SQL. You can write either object oriented approach query language, or you can use direct SQL queries. And we have other ecosystem, other framework in Spark, Spark streaming, like Flume, we have Spark streaming, but here it provides only capturing data from streaming sources and writes into Hadoop, but it will provide streaming plus live analytics. So we can write analytic applications while reading the data. So this is the main advantage of Spark streaming compared to Flume. And next one, Spark mlib. It is a machine learning library. We can train any system by using Spark mlib. Spark mlib provides different algorithms By using those algorithms, we can train our missions. Next one, Spark graphics. Spark graphics. Linked data processing. Linked data or graph data. Graph data. So let's say social media friends. Whenever new friends join in any friend, automatically it will show mutual friends request to all that person friends, right? So such kind of data we call linked data, graph data thing. So Spark graphics is specialized in processing linked data. So these are important components in Spark thing. How Hadoop has different frameworks, Spark also has different components too. Different components. Next one. Next important difference too. So Spark is 100% or 100 times faster than MapReduce. 100 times faster than MapReduce in memory computing. In memory computing means RAM memory. Spark is 10 times faster than MapReduce in disk computing thing. Spark is 10 times faster than disk computing. By default, it is in memory computing. We all know MapReduce is a fastest processing compared to any existed frameworks. Before Spark, MapReduce is a proven technology. It is a fastest processing framework. It is a parallel processing framework. Compared to MapReduce, Spark is 100 times faster. This is one more important reason people are going for Spark as processing. Next important difference, very important difference. MapReduce, we can run only on yarn architecture. We can run only on yarn architecture. Means Hadoop cluster. MapReduce applications or pick queries or Hive queries or scoop queries, we can run only on Hadoop architecture. But Spark applications, we can run on first one, Spark standalone master slave architecture. Next one, yarn architecture, and we can run on Mesos architecture, and Kubernetes. It is not yet implemented. It is started implementing, but still in R&D phase. So Spark applications we can directly run on any of these frameworks or runtime environments. But MapReduce, to run MapReduce, we need yarn architecture only. There is no other alternative. But Spark applications we can run on any of mainly these three frameworks. Hadoop is not mandatory. Many people thinking that to learn Spark, Hadoop is mandatory. Noting, Hadoop is optional because it is completely processing. So it takes any of these inputs any of these inputs. Output also it will write in any of these output locations. It may take any input, it may write in any output. It is not tightly coupled with the Hadoop HDFS file system. It can process any data. That's why we are saying it's a big data processing framework. Don't think big data means only Hadoop. Any huge volumes of data, we call it as big data type. So Spark is specialized in processing. It has only processing. It does not have a storage. So majorly we have these 5 components team: Spark Core, Spark SQL, Spark Streaming, Spark Emblem, Spark Graphics. Okay. Let's understand Spark jobs in real world. We have 2 kinds of job setting: Spark developers, and second one Spark ML developer, Spark machine learning developer, or we can say Spark data scientist. Spark data scientist. Spark data scientist team. We have 2 job roles: Spark developers or Spark machine learning developers. As part of Spark developer, first one, Spark Foundation. So here we are going to understand what is Spark, advantages of Spark, and Spark programming structure, Spark installation and Spark programming structure, and first Spark application. So before going to write a Spark application, what are required to develop Spark? Means Spark application development prerequisites. And we will see first Spark application team. Once it is completed Spark Foundation, then we start with Spark Core. Here we are going to discuss Spark means RDD programming team. Here we are going to learn transformations and actions. Next one team, third one, Spark SQL. So as part of Spark SQL, we are going to learn what are data frames, data sets, tables. Okay. So how to process these data frames data sets data, table data using DSL language, domain specific language, domain specific language, or native SQL means SQL. So domain specific language is very simple and easy. It is object oriented approach. If anyone feeling difficulty, they can directly write a native SQL. Who has a very good experience in SQL, they can write their SQLs on tables. Next one, fourth one team, Spark streaming. So here we are going to see streaming plus live analytics team. So for this one, here after Spark Foundation, we will understand importance of Scala. So we are going to learn Scala for Spark, not in-depth Scala team. Whatever required, we are going to discuss all those Scala for Spark. Next one, Spark core programming, Spark SQL programming, Spark streaming, and next one, sixth one, Spark integrations. Spark integrations. So here we are going to learn HDFS file system and Hive integration, RDBMS integration. Here we are going to see MySQL integration. Next one, NoSQL integration. So here we are going to see Cassandra. Next one, team, Kafka integration. Either Kafka or Flume, we are going to integrate by using in Spark integration team. So this is developer course. So next one, team, Spark machine learning developer. Spark machine learning developer. For Spark machine learning developer team, so first prerequisite is Spark developer course team. Prerequisite. Prerequisite is Spark developer. Spark developer course, then Spark mlib. Spark mlib. Second one, Spark graphics. Spark graphics. So we have two different courses. One is Spark developer course and other one is Spark machine learning developer. So as part of this Spark and Scala, we are going to discuss what? Spark developer course team. Spark developer. Let's start him. In this session, we are going to discuss development environment and runtime environment. So development and runtime environment. Let's first discuss development environment today. Development environment. So first one, every developer mission is Windows mission team. Every developer mission, Windows mission. Most of the time, developer missions are Windows missions. So developer mission. So in this developer mission, software setting, we install so first one, Java we install team, Java 8. On top of Java 8, we are going to install Scala. On top of Scala, we are going to install Spark. So this is our software stack. So we are going to install all these softwares in developer mission. First one, first important one, we are going to install these softwares. After installing these softwares, we are going to install IDEs. So we are going to install any IDE. It may be Eclipse IDE, or it may be Scala IDE, or we use IntelliJ, etc. So we use IDE software team. In this we write Spark application. We write Spark application. Then we run this Spark application in local machine. So in local machine, to run this Spark application, we have a Spark software. So you can run your Spark application in local machine. After developing, to test whether your instructions are working properly or not, we can run this application in local machine team. So developer or development mission, developer mission. Development environment. So development environment. So softwares we use operating system. Most of the time development missions are Windows operating system, and language we use Scala language. Framework we use Spark. Next one, build tool. We can use either Maven or SBT. It is recommended for Spark and Scala or Scala projects setting. SBT is specialized in Scala projects. Next one, IDE software. We use either Eclipse IDE or we use IntelliJ. So IntelliJ is recommended team, not mandatory, recommended. Most of Scala based projects or Spark based projects, most of the people prefer IntelliJ for development. You can develop Spark applications in Eclipse also team. You can use Maven build tool, or you can use SBT. SBT is specialized for Scala. So this is our development environment. Once application is developed, we run applications in developer mission to test whether instructions are running or not with sample data sets, because developer missions are memories are less. So we test our application with the sample data. If everything working fine, we deploy this application into runtime environment. Okay. So one more important point here. So these are different environments. Once application developed, once application is developed, we can run or debug Spark applications in developer mission team. Once we feel application is working properly, then we will deploy our applications into runtime environment. Until application completion, we will not deploy. We will test everything in a developer mission. Okay. So here one more important point. We can develop Spark applications, Spark and Scala applications. We can develop a Spark and Scala applications in one interactive mode. So this is only for development, not for testing purpose, not for production. We will discuss clearly. Second one, script mode. It is recommended. Here we use IDE softwares for development. So to develop a script mode applications, we use IDE software team. So what is interactive mode? What is script mode? We are going to see coming lessons. So this is complete development environment. Next one, runtime environment. So once application is successfully developed, let's say, so this is our developed application. Let's take this one. So application is completed. So this application is completed. So multiple statements are written in this application. Maybe Spark Core, maybe Spark SQL, maybe Spark Streaming, maybe other Spark framework instructions, component instructions, or combination of Spark components. So we developed multiple statements. So all statements are working properly. So we tested in our local machine. Then once development is completed team, we can deploy our applications in 3 environments team, any of 3 environments, not in all 3 environments, any of 3 environments. Let's say this may be Spark standalone master slave architecture. This may be Spark standalone master slave architecture, or it may be Yarn architecture, it may be Mesos architecture too. So it may be Spark standalone master slave architecture, master slave architecture. Next one, it may be Yarn architecture. So Yarn architecture means Hadoop cluster team. Hadoop cluster. So it may be Mesos architecture. So once we develop application team, so what we are going to do, we will convert this application into jar file team. We will convert this one into application jar. So application jar, app.jar file team, app.jar file. So we convert application into jar file by using Spark submit utility. By using Spark-submit utility, we can submit our Spark application to either Spark standalone master slave architecture, Spark standalone master slave architecture, or we can submit the Spark application to Mesos architecture, or we can submit a Spark application to Yarn cluster team. So there is one concept called Spark Submit. By using Spark Submit utility, we can submit a Spark application to any of these three environments. So runtime. So we can run Spark applications. We can run Spark applications. We can run Spark applications on any of three environments. They are, so one Spark standalone, master slave architecture, Spark standalone, master slave architecture. Okay. Second one team, Yarn architecture. So Yarn nothing but Hadoop cluster. So third one, Mesos architecture. These three architectures are introduced by Apache team, Apache vendors. So once application is developed, we can run Spark applications on any of these three environments team. So to run Spark applications, we use Spark-submit utility. Spark-submit utility. So we convert our application into jar file. We convert Spark application into jar file team. Spark application into jar file, and then we will run on above three environments, above any of three environments. So we convert our application into jar file by using Spark submit utility. Spark submit utility. Spark submit utility. We can submit our Spark application to any of three environments. It may be standalone, it may be Yarn architecture, it may be Mesos architecture. Most of the time we submit our Spark application to Yarn cluster because data is already presented in Hadoop cluster. So most of the time we submit our Spark application to Yarn cluster. I'm not saying all applications on Yarn architecture. Most of the time. Or some people creates their own Spark standalone master slave architecture and they will run Spark applications on Spark standalone master slave architecture. Okay. So this is runtime environment team. Runtime environment. Okay. So is it clear team? So development we use in Windows environment. Runtime we use any of these three environments. Is it clear team how we are going to develop applications in developer mission and how we are going to deploy or run our Spark applications into runtime environment? We are going to discuss Spark architecture in depth so that you will get a clear understanding how we are going to deploy Spark applications. Okay. So clear, right team? Yeah. Let's see team. In this session, we are going to discuss Spark installation on Windows operating system. So first one, Spark software is implemented using Scala language. Spark software implemented implemented using Scala language. So Spark software implemented using Scala language. To run any Scala applications, Scala applications, we need JVM. JVM stands for Java Virtual Machine Team. JVM stands for Java Virtual Machine. Java Virtual Machine. So JVM stands for Java Virtual Machine. It comes along with JDK. It comes along with JDK. So JDK stands for Java Development Kit. JDK stands for Java Development Kit team. So simply we can say Java software. Java software. So for developing Spark applications, first we need Java. On top of Java, we need Scala. On top of Scala, we install Spark team. Okay. So let's clearly and diagrammatically discuss it. So this is our developer mission. So developers missions always Windows OS. Maximum developer missions are Windows operating system. Okay. First one. So first important, we have operating system team. On top of operating system, so this operating system may be any operating system. On top of operating system, first we will install Java software. So Java. So recommended version is Java 8.13. So this is recommended. So Java 8 is recommended team. Next one team. If you want PySpark, you need to install Python team. If you want PySpark, you need to install Python. If you want to Spark and Scala, you need to install Scala team. So you can install either Python or Scala. If you want both, install Python and Scala team. If you want both Spark and Scala, PySpark, install both. On top of this one, we will install Spark team. We will install Spark. On top of Python or Scala, we will install Spark. Then we will write Spark applications using different IDE softwares. So using IDE softwares, we will develop IDE softwares. If it is a PySpark, we use IDE softwares like PyCharm. So we use Spider, PyCharm, Jupyter Notebook, etc. If it is Spark and Scala, we use IntelliJ, we use Eclipse, we use Scala IDE, etc. So we use different IDEs. If it is Scala, we use different IDEs. If PySpark, we use different IDEs team for developing Spark applications. So in this way, we will set up our developer environment team. Okay. So first, if you want to install Spark in your machine, first we need to install Java 8 recommended to install. Second one, we need to install Scala. If it is Spark and Scala. If it is PySpark, we install Python. So for PySpark. So third one, we will install Spark team. For Spark again, we have two steps. A, WinUtils, and B, Spark installation. So these are three important softwares we have to install. 1 minute. Yep. Let's understand Java 8 installation thing. So first one, download Java 8. Download Java 8. Second one, install Java 8. And third one, set Java_home and path variable. And fourth one, verify Java is installed or not. So these are four important steps we are going to do as part of Java installation. First one, download Java 8 team. Download Java 8. Yep, downloading Java 8. So open any web browser. And browse Java 8 download team. So I'm opening Google Chrome. Let's search Java 8 download. So click on second link, oracle.com. So this is Oracle is the vendor of Java. So select this Oracle link. Let's scroll down. Here it is showing Java for different operating systems. And end of the location we see Windows x86, Windows x64. Windows x64 is Windows 64-bit supported version. Click on this exe file. So accept the license agreement team. Click on this download JDK. It will open login link team. Oracle login link. So you have to create account in oracle.com. Then you have to enter login details. Then only it will start downloading. Okay. So once download is completed, team, installation is very easy. Installing Java 8. Next important topic is installing Java 8. So double click on downloaded exe file. downloaded.exe file and choose all default options. Choose all default options team. So I always recommend choose all default options while installing Java. Okay, first important point. Let's wait to download team. Yep. So once that pop-up window, if you enter your login credentials, it will start downloading team. In my mission, I have already downloaded JDK. So this is latest version 8.251. So next one, let's double click on this downloaded .exe file team. Double click on this exe file and click on yes button. Then it will start installing team. Let's wait. Yeah, it is started. So click on next button. So choose all default options team. Click on next. Yep. So click on next button. Then it is started installing Java. So once installation is completed team, then we will set Java path variable team. We will set Java underscore home path variable. So first one, why we need to set Java underscore home. Why we need to set Java underscore home? Why we need to set path variable thing. Path variable. First one, Java underscore home. Java underscore home, we set up to Java underscore home, we set up to path. Let me click on close. Let's go to C drive. Under C drive, program files. Under program files, Java. Click on JDK. So this is the path. So Java home, we set up to this path. Path variable, we set up to Java underscore home slash bin. Now let's understand why we need to set Java underscore home. Many softwares which developed based on Java, like Hadoop, and there are plenty of softwares which were implemented using Java. Maven, IDE softwares, standalone softwares. Many softwares which are implemented by using Java refers this Java underscore home to find jar files, maybe configuration, maybe Java executables. It will refer Java underscore home. So to give indication to the softwares which developed using Java, a softwares Java path is presented. Java path is presented in this location. So we are indicating third-party softwares which are implemented using Java. A third-party softwares Java installed in this location. Okay. Next one, path variable. Inside a bin, under Java underscore home, inside a bin, we have different Java commands like Java C command, Java command, jar command, Java doc command, Java H command, Java P command. To make all these commands available anywhere in our computer team. To make all these commands available anywhere in our computer, we will set Java underscore home. So first one, before bin path, we will set Java underscore home. So open my computer or right click on this PC, click on properties, click on advanced system settings, click on environment variable. Here we have user variables, system variables, user variable only for currently logged in user, system variable for any user in this computer. I always recommend system variables. Click on new, type Java underscore home, paste this before bin path, click on OK. Okay, next one thing. Next one, path variable. So same. So come to until environment variable. Here already path variable is presented. Select path variable. Click on edit. Here click on new. Then we can enter complete path until bin. Until bin we can enter, or I always recommend refer Java underscore home percentage Java underscore home percentage / bin. Why I recommend this version, this approach is, in our system we may have Java 8, we may have Java 9, we may have Java 10, Java 11, Java 12, any of software stream. So every time, instead of changing that path variable here, we change only Java underscore home location, so that will reflect in all the locations where we are referring percentage Java underscore home. Okay, click on OK, click on OK, click on OK. So Java installation is successful thing. Now verify Java is installed or not. Now let's verify Java is installed or not. So for this one thing, we will open a command prompt. Let me close. Open command prompt. Open command prompt. Type Java space hyphen version or Java C or Java P. Java C command, Java P command, Java command. It will display different options setting. When you see any options, then we can confirm Java is successful. Java is successful thing. So we open command prompt. We will type Java space hyphen version. Next one, command prompt Java C, or we can open command prompt and we can type Java command. If it shows any options, means Java is successfully installed. It is showing options, right? Java is successfully installed. So whatever the version we installed, right, we downloaded, same version it is showing thing. Okay, so that's it for Java installation. That's it for Java installation on Windows operating system. Let's understand it. Scala is a language. Scala is a language. It is a JVM based language. It is a JVM based language. It is a JVM based language. So before install Scala, make sure Java 8 or JDK 8 should be installed. Team, because once we develop any Scala applications, To run that Scala applications, we require JVM. Scala is a JVM based language. Okay, so we have already installed Java 8 in our machine. We have already installed verified. Now download Scala. Second one, install Scala, and third one, set Scala underscore home and path variable Scala underscore home, and fourth one, verify Scala is installed or not. Scala is installed or not. So first one, downloading Scala. Team. Open any web browser. Then search Scala and go to scala.org. Search Scala download, scalalang.org. Click on this scala.lang.org. This is download link thing. Here it is showing 3 options thing. Observe what are those 3 options. First option, make sure Java 8 or JDK 8 or latest version of Java is installed. Yes, we have already installed. Scala version, current version is 2.13.3. Okay. Second one, install IntelliJ or download SBT. Along with this one, you can also install Scala. This is second option. And I recommend the third option, download Scala binaries for Windows. Click on this option. It will start downloading Scala. In my mission, I have already downloaded Scala software. Okay, Scala 2.13.3. So you can download your Scala from this link. Okay, once the download is completed, install Scala. Installation of Scala is very easy thing. Double click on .exe or MSI and choose all default options. Choose all default options thing. That's it. Okay, so go to download location, double click on this Scala and all default options thing. Accept a license agreement, click on next, click on install. Click on yes button, then it will start installing. Once installation is completed, then set Scala underscore home and path variable. Set Scala underscore home path variable. So first important pointer, why we need to set Scala underscore home. Okay, why we need to set path variable. So one important point here, many softwares implemented using Scala language like Akka framework, Play framework, Spark framework, Kafka framework. Plenty of softwares were most popular. Plenty of softwares were implemented using Scala language team. So these softwares refers Scala underscore home to run their softwares. And we know, and bin directory contain Scala commands. So Scala underscore home, we set up to before bin path thing. Click on finish. Go to C drive. Go to, it is 32 bit version is availability. Click on program files x86. Here you will see Scala. Here you see bin directory. Here we have different commands. Before bin path is Scala underscore home. So up to bin path is path variable. So to make all commands presented in bin directory, we are going to set path variable. So first to copy this one. Okay. So open folder, right click on this PC, properties, advanced system settings, click on environment variable, user variables and system variables. I recommend system variables. Click on new, type Scala underscore home and paste the value. Click OK. Next one, path variable. Path variable is already existed. Click on edit. Here, click on new. You can enter complete path or already path is presentative. Path is, when you install, it comes automatically. I never recommend this approach. Click on new. I recommend percentage Scala underscore home percentage / bin. Why I recommend this approach? Because in our system we can install any number of versions of Scala. So required version we configured in Scala underscore home. So refer this path so that you will get exact Scala version. Click on OK, click on OK, click on OK. Close this one. Now verify Scala is installed or not. Verify Scala is installed or not. So for this one, we use Scala space version. Open command prompt, type Scala -version team. This is one way. So open command prompt and type Scala space -version. If I type this one, we are going to see Scala code runner version 2.13.3. So this is Scala version 2. Now we can confirm Scala is successfully installed. Clear? So that's it for Scala installation team. Now let's start Spark installation. So first, as part of Spark installation, we understand we install Java 8. On top of Java 8, we install Scala or Python. Next, on top of this, we install Spark. So previous session, we installed Java, we installed Scala. Now let's see Spark installation tip. Spark installation. So as part of this step, first we will install WinUtils. Next we install Spark team. So why WinUtils is required? Let me show one as part of this Spark installation step. Let me show Spark. Yep, Spark download. Click on this Spark download. See, if you observe here, Spark download is available for pre-built for Apache Hadoop. Spark download. Now let's understand. So we discussed as part of Spark installation, we discussed Java 8 installation and we discussed Scala installation. So we are installing Spark and Scala. If it is a PySpark, we need Python. If you want both, install Scala and install Python. Now let's see Spark installation. So as part of a Spark installation, first we prerequisite Java, Scala or Python should be installed. Java and Scala or Python or both. After that, we will install Spark. So Spark installation required Hadoop. For writing any Spark application, Hadoop is not mandatory. It is optional. For Spark development, Hadoop is optional thing. It is not mandatory. Just Spark installation expecting Hadoop presented in our mission. So for that one, in Windows, instead of Hadoop installation, we will install WinUtils and we will set up Hadoop_home. Then after that, we will install Spark team. Installation. WinUtils installation. So first one, download WinUtils. WinUtils team. Download WinUtils. Second one, create a directory under any location. Let's say I'm creating under C. Under this, I'm creating WinUtils. Under WinUtils, I'm going to create bin directory. In this bin directory, I'm going to place winutils.exe. winutils.exe. Okay. Then after that, set Hadoop_home. Set Hadoop_home. We are making Spark. I have Hadoop. That's it. Just to make Spark happy, we are setting. We have Hadoop. Okay. So first, let's go open C drive. Go to C drive. Here I am creating one folder. WinUtils. Under WinUtils, I am going to create one folder, bin. Okay. So now let's go to any browser, open any browser, open any web browser and search WinUtils, winutils.exe download. Click on this first link team. Let's scroll down. Here we see winutils.exe. So current Hadoop is expecting Hadoop 2.7. So I'm looking Hadoop 2.7. Click on this Hadoop 2.7.1. Click on bin. So let's scroll down. Here we see winutils.exe. Click on this winutils.exe. Let's click on download. So let's download this one under C drive, under winutils, under bin. Let's click on download. Downloaded successfully. So we created folder. Under this folder, we downloaded exe. Now let's set Hadoop underscore home. So go to winutils team. Copy this path before bin path team. Copy before bin path. Copy this one. Right click on this PC. Click on properties. Click on advanced system settings. Click on environment variable. Here we have user variables, system variables. You can create Hadoop underscore home anywhere. I always recommend system variable because system variables are available for every user. Click on new, type Hadoop underscore home, type Hadoop underscore home, set value. Click on OK, click on OK, click on OK. Okay, next one thing. So winutils is successful. Now Spark installation. Now Spark installation team. So this one team, first step 1, download Spark. Download Spark. Step 2, install Spark. Step 3, set Spark underscore home, Spark underscore home, and path variable. Spark underscore home and path variable. Next one, step 4, verify Spark is installed or not. Spark is installed or not. Okay, verify Spark is installed or not. So first one, downloading Spark. Open any web browser, search Spark download. Click on this downloads Spark. So this is download path. Okay, here we see Spark release 3.0.0 is latest version, and I'm choosing 2.4.6. And here choose package type is pre-built for Hadoop. That's why we downloaded winutils. We set up Hadoop underscore home. Now click on Spark -bin Hadoop 2.7.0.tz. Click on this tz file. Click this link. Then start downloading it. It is starting downloading. So meanwhile, let's understand another step. So installation is installation. So we downloaded Spark. So after downloading, we are going to do install Spark thing. Install of Spark nothing but installation nothing but first step, extract tar file. Extract tar file. B, optionally rename, and C, optionally rename, remove tar file. This is also optional. Extracting tar file is nothing but installation team. We can use any software like WinZip, we can use WinZip, WinRAR, or 7zip, etc. to extract a tar file team. Once extracted, rename. It is optional. Then remove tar file. This is also optional. Once installation is completed, we are going to set a Spark underscore home and path variable. Spark underscore home, path variable team. Why Spark underscore home? Spark underscore home, we set up to before bin path team. Let's wait and see download and extracting. Inside extracted folder, what are important subdirectories are available? What is the purpose of each directory? We will discuss. Let's wait team. Yep. So Spark is downloaded successfully. Let's copy this downloaded file. And I'm placing this downloaded file in my F drive under C family, under software, under big data. Let's place this one. So downloaded successfully team. Now installing. Installing means extracting tar file. So right click on this one and go to 7zip, extract here. .tzz file comes to .tar file. Right click on this tar file. Again go to 7zip, extract here. It is extracted successfully. I am removing both tar file and gz file. And second step, optionally rename. Instead of this lengthy name team, I am renaming this one to Spark. Okay, so renaming is successful. Now, third step team, set Spark underscore home and path variable. Set Spark underscore home, path variable. So here, let's go Spark in Spark. In this Spark, if you observe, we have bin directory, config directory, jars directory, Python directory, sbin directory, yarn directory. First, let's go to bin directory. Here we can see different Spark commands to start Spark Scala, Spark-cell, Spark-cell to start Spark and Scala. To start PySpark, we have a PySpark command and other commands too. So these are different commands available in bin directory. In configuration, we have a different configuration files, and let's go to very important one, jars. Here important all required jar files are presented in this location. And next one, Python related jar files are presented under Python. Here we have libs. These two are Python related, PySpark related library files. So this Spark installation contains many important directories. So we are setting Spark underscore. We are setting Spark underscore home. Next one, path variable. Path variable we set up to bin path team to make all Spark commands available anywhere in our system. Okay. So first one, go to this PC, right click on this PC, click on properties, click on advanced system setting, click on environment variable. So go to system variables, user variables only for currently logged in user. System variables are for any user in this system. Click on new, type Spark underscore home, Spark underscore home, and the value is before bin. Okay. Next one, path variable thing. Path variable is already existed. Search the path variable here. This is path variable. Click on edit. Here you can click on new. You can type until. This is one way. I recommend, instead of entering this complete path, percentage spark underscore home percentage slash bin. I recommend this approach. Why I am recommending this approach is, in our system, we may have different versions of Spark. We may have 1.x, we may have 2.x, we may have 3.x. So whatever the version we want to use for our application development, we set that version in Spark underscore home team. So instead of changing Spark version in different locations, if you configure like this, it will automatically refers to Spark underscore home. Okay, click on OK, click on OK, click on OK. So installation configuration is completed. Let's verify Spark and Scala installed or not. Very, very important step. Verify Spark is installed or not. So open command prompt team. Open command prompt. Open command prompt. Type Spark -cell. It will start. It will start Spark and opens Scala prompt. Scala prompt. First one, it will start Spark and opens Scala prompt. Here we can write. Here we can write. Here we can write any Spark instructions. Spark instructions team. Any Spark instructions. Open command prompt and type Spark -cell. Press enter. Let's wait. Start Spark. Click on allow. So it is started successfully. Spark banner. Are you seeing Spark banner? Version is 2.4.6. It is started Scala prompt. Successfully it is started. Here we can write any statements like print welcome to println, welcome to Spark world. We are writing simple PySpark statement, printf statement. Let's understand important point about this cell team. Very important point. When you start Spark using Spark -cell command, when you start Spark using Spark -cell command, it will create Spark context, Spark context, and Spark session, Spark session automatically, Spark context and Spark session. So Spark context is available using variable sc. When I type sc, you will see org.apache.spark context. When I type Spark, I am seeing org.apache.spark.sql, sql.spark session. So these two variables are already created. No need to create manually. What are these variables? We are going to discuss in coming session, but just understanding. So by default, these two variables are created. No need to create explicitly. Whenever you use Spark-cell, it will automatically created. Okay, did you understand how to install Spark in Windows operating system? So first we followed Java installation. Next we install Scala. Next we install Spark. Then we started Spark. Okay. So let's start. In this session, we are going to discuss Spark and Scala programming. So first, let's understand introduction. Spark and Scala programming introduction team. We can develop Spark and Scala programming, Spark and Scala programs or applications. Spark and Scala programs or applications in two ways. Two ways. One, interactive mode. Second one, script mode. Interactive mode and script mode. Interactive mode, we use Spark-cell. Interactive mode, we use Spark-cell. Okay. Script mode, we use IDE softwares. IDE stands for interactive development environment. Interactive development environment. So Spark and Scala application development we do in two modes. One is interactive mode and other one is script mode. So we have two modes. You can directly write statements step by step, or you can write one script file. In that script file, you can write Spark and Scala instructions. Okay, these are two ways. First, let's see interactive mode. In this mode, we will develop Spark and Scala statements. Spark and Scala statements step by step. Statements step by step. Step by step. Each step we get output in a console. Each step output we can see in a console. This is the main advantage of interactive mode team. Each step output we can see in a console. This is the main advantage of interactive mode. Okay, first one. Next one is, if there is any error, if there is any error or wrong output, we can immediately correct. We can immediately correct it. We can immediately correct. This is one more advantage. This is only for this mode only for development, not for testing purpose, and not for production purpose. This mode is not for production, not for testing. This is only for development team. How to start interactive mode? How to start interactive mode? How to start interactive mode? So this one team, open command prompt, type spark-cell command. It will start Spark and opens Scala cell. It opens Scala cell team. So Spark-cell command starts Spark and opens Scala cell. Let me let me go to workspace. Let's create a folder. Spark Foundation. In this Spark Foundation, let's open command prompt. Let's type a Spark-cell team. First one, let's type a Spark-cell. It will start Spark and opens Scala cell. This Scala cell we call interactive cell. Let's write it. So meanwhile, we'll discuss about the first Spark example in interactive mode. First Spark example in interactive mode. So for this one, we are going to implement a task is read local file system, and apply Spark processing. Team. So we are going to discuss one simple example, reading local file system and applying Spark processing. So it is started Spark. Spark team. Okay. Let's see first Spark example in interactive mode. So I have data directory in the C family. Data directory. I have a comment file. Let me open comment file. So I have a 4 lines, 4 rows. I want to read this comment.txt file and I want to apply some Spark processing. So first requirement is read local file system and apply Spark processing. So one important note. in interactive mode, Spark context is already created. In interactive mode, Spark context is already created with variable SC. So no need to create a Spark context object. It is already created. So first one, what is Spark context? What is Spark context? First, let's understand it. It is a starting point of. It is a starting point of any Spark application. Any Spark application. It is a predefined class. It is a predefined class. Predefined class. It is a predefined class. So we have to create this Spark context object first. In interactive mode, this class object is already created. This class object is already created. No need to create explicitly. So there is one variable print SC. Then we can see org.apache.spark context. So it is presented in this package team. It is a predefined class present in which package? org.apache.spark context. So this class is by default created, and I said one important point in previous session while installing Spark in our Windows machine. Did you remember we installed Spark in FDrive under family, under software, under big data? This is our Spark. Click on this Spark. In this Spark, we see jar files. In this jar file, let's see Spark-core. Let's see Spark-core. This is Spark-core jar file. Are you seeing it? This is Spark-core jar file. This jar file contains Spark context. So important point to you. This class, this Spark context class presented in Spark-core jar file. Spark-core jar file. No need to download this jar file. It is already available as part of Spark installation. So under Spark home, there is a directory called jars. In that jars, we have a Spark-core jar file thing. Okay. So that jar file contains this predefined class. Okay. Now let's implement our program thing. So first sc.text file, and here we pass file name as an input. File name as input. It will read file and creates RDD. So I am creating that RDD in one variable called val rd1. So first, where is our data directory? Under C family, under data directory, we have a comment.txt. So first one, we are loading data. So file name is comment.txt. So here, let me explain this syntax. Text file Inside parenthesis, we put double quotes. Inside double quotes, we pass file name path, complete path. So inside this double quotes, we used slashes for backward slashes. We call these are backward slashes. If you use backward slash t, after backward slash, it will expect formatting characters like slash n, slash t, slash n, slash t, slash r, etc. Because in Java, in Scala, in Python, most of the languages inside a double quotes, after backslash, it will expect a formatting character. To give indication to Scala or any other language, we pass two forward slash so that it will understand this is a path separator. Okay. So it will read local file, creates RDD. What is RDD? We are going to discuss in depth. Now I want to print println RDD dot count. RDD dot count. How many records it is showing? 4 records. I want to print 4 rows. RDD dot collect is a predefined function. Collect dot for each println. For each println. So collect function reads all rows. From this all rows, for each function reads row by row and passes to println. Println prints message in a console. So it is printing all rows. Instead of printing all rows, we can print only specified number of rows using take function. Take function can read specified number of rows. I want to read only 2 rows. Yep. So let's copy this complete syntax. Okay. Let's discuss step by step. In this example, what we did, let's explain. First statement. I am explaining about text file function. Okay. So Spark context class has text file function, comma, whole text files, make RDD, and parallelize function to create RDDs, string. Has different functions to create RDD. Text file function, whole text files function, make RDD function, parallelize function. First, let's understand RDD. Briefly understand RDD. RDD is a storage object. In Spark. Like variables in languages. First one. Second one. So we understand text file function. We understand RDD. Now let's understand count is a predefined function in RDD. In RDD, we have different functions. Functions like count. returns number of rows of RDD, number of rows of RDD team. First one. Second one, collect function. Collect function returns all the rows. Returns all the rows. Take function, take of n, returns specified number of rows. Specified number of rows. So RDD is a storage object to store the data like a variables in languages. In languages, we use variables for storing the data, right? Here, to store the files data. To store the files data, we use RDD. So it's a storage object. We are going to discuss in depth about what is RDD later. Now let's understand it is like a variable. To store the loaded data in Spark, we use RDD string. So clear? We understand Spark first in interactive. First Spark example in interactive mode. Okay. Let's starting. In previous session, we understand what is interactive mode. How to develop Spark applications in interactive mode. So we use Spark cell command. We opened a command prompt. We typed Spark-cell. It will start Spark and opens Scala prompt. There we will write statement step by step. Yes or no? Now let's understand script mode. So first, script mode means in script mode, we will write all statements first. We will write all statements first, and later we will run. So later we will run. First one, we will write all statements. Later we will run. Interactive mode, we will write statement. Whenever we press enter, it will execute that statement. So step by step development in interactive mode. But in script mode, first we will write all statements. Later we will run. Okay. So it is faster development. It is faster development. Faster development, first one. And next one, it is for development, testing purpose, testing and production team. It is for development, testing and production. So we will write a script. With all the statements. We save as a .scala. We save program as a .scala. We give this .scala program to tester. Hey tester, you can test this program. After testing the program, they will move to production, means live server. They will place our .scala programs in production server. Any client can send a request to this .scala programs team. So this script mode programs are for development purpose, testing purpose and production purpose. Interactive mode only for development, not for testing, not for production. When we go for interactive mode, when we go for script mode, we will discuss interactive mode versus script mode. Okay. Yeah. First important point. First important point is script mode is for development, testing, production. We will write all statements and we will save as a one file with the extension is .scala. Okay. Yeah. So let me yeah. Next important point, to write script mode, to write the script mode, we use editors. We use editors like Notepad, Notepad plus plus, Notepad plus plus in Windows, in Windows 10. Okay, VI, Vim, gedit, nano in Linux, team. So we use Notepad, WordPad kind of softwares in Windows operating system. Vim, VI, gedit, nano kind of editors in Linux or Unix environment team. And next one, IDE softwares. IDE stands for interactive development environment. Interactive development environment like IntelliJ, Eclipse, Scala IDE, Scala. There are plenty of IDE softwares in the market team. So preferable is IDE softwares are recommended. And here we are going to use IntelliJ. IntelliJ is recommended. It is Scala recommended, Scala supported IDE, and remaining also Scala supported. We have to add plugins like IntelliJ team. So IntelliJ is one of the recommended IDE for developing script mode applications. Spark and Scala in a script mode team. Spark and Scala in a script mode. So you can use Eclipse also, you can use Scala IDE also. There are plenty of IDE softwares available in the market. You can use any. And we have editors, we have IDE softwares. Why? Which is preferred? Not why. Which is preferred? Is editors are preferred? Is IDE softwares are preferred? So most of the people uses IDE software team because Notepad plus plus, we will write programs in editors like this Notepad or Notepad plus plus and running in command prompt. So development is one location, runtime is different location. This is one reason. Second reason, in Notepad, we cannot get any help for developing Spark and Scala application team. Help like predefined class names, predefined functions, auto help, auto population, auto save. These features are not available in Notepad editors. If you go for IDE software provides development area, runtime area. Development area, runtime area. First important point, development area, runtime area. Next one, while developing, if it is any predefined class, it will show auto population thing. You can develop very faster by choosing predefined function names, predefined classes. There are a lot of help is presented in IDE softwares. That's why it is recommended. So script mode development recommended is IDE softwares. You can use editors, but recommended is IDE software. If use IDE software, application development is faster. And IDE software, so classes, it will show different color, and functions, it will show different color, predefined keywords will show different colors. There are many benefits if you use IDE software step. There are many benefits. That's why people uses IDE softwares for developing. In industry also, we will use IDE softwares like IntelliJ, Eclipse IDE. IntelliJ provides free and enterprise version, licensed version, but Eclipse is completely free. Eclipse is completely free thing. It's a open source and free. No need to pay single rupee for Eclipse software. But IntelliJ has both free and enterprise version. For our Spark and Scala development, free version is enough. Free version is enough. There are additional features in enterprise version. If you want to use additional features, then only we need enterprise version. Generally, I prefer free version, community version for developing Spark and Scala applications. Okay. Yeah. Let's see, team. Write first Spark application. Write the first Spark application in IDE. So here we are using IntelliJ IDE. IntelliJ IDE 18. Writing first Spark application. So first one, step one. Step one, IntelliJ should be installed. Should be installed before writing. Okay. Next, and start IntelliJ and start IntelliJ. So already IntelliJ is installed. So go to desktop team. This is our IntelliJ. Double click on this IntelliJ. So click on OK. So next one, team. Next one, team. Here, step 2. Yep. Click on create new project. So step 2. Step 2. Create new project, team. Create new project. New project. So very important to know. Start IntelliJ. Here notice IntelliJ should be installed. Okay. So create new project. Here important to notice Scala plugin should be added. If not, we need to add. We need to add Scala plugin. We need to add. How to verify Scala plugin is added or not? So here, click on new project here. Click on new project. Click on new project team. Here it will show. Scala. Is there any Scala option? No. It means Scala plugin is not presented. Scala plugin is not presented. Then how could we add plugin? Here we have a configure. click on configure, click on plugins, click on plugins. Here, let's wait till it is important. It is going to display. Here we see Scala. If it is not presented, type Scala here. If it not shows list of options, type Scala. First one we are seeing Scala, right? Click on install. Click on install. So Scala plugin is downloaded and installed in IntelliJ. Then click on restart IDE. Just to click on restart IDE, it will restart IDE. Then once again we will verify Scala project is presented or not. Okay, click on create new project. This time it will show Scala plugin, yes or no. Previously we did not say Scala plugin. Now we are seeing Scala plugin. Okay, so create a new project. We clicked on create new project. It is showing Scala SBT. So select in this, select Scala SBT. SBT, click on next button. Click on next button. It will ask project name. Project name. So first one, project name, I am selecting location. So select the location team. So we are creating all the projects under D drive, under C family, under big data, under Spark and Scala. We created a workspace. In this we created Spark Foundation. Yes or no? So in this Spark Foundation, we are creating project. Okay. So second one, project name we given Spark Foundation. In this Spark Foundation, let's say Spark Foundation, let's create a new folder first. Okay, let's create. So we created project name, we created first, and location you can create anywhere. Okay. Next, JDK team, JDK 1.8. This is recommended. 1.8 is recommended. So it is selected by default JDK 1.8. Next, SBT leave default. SBT take default. So whatever the default SBT option is presented, take as it is. Second one, Scala. Here thing, select 2.12.x version. Spark supporting Scala 2.12.x version. Scala latest is 2.13.x. Spark not supporting. So I recommend select Scala Scala version 2.12. Okay. So here under this version, you will see Scala 2.12. I am selecting 2.12, Scala 2.12. Click on finish. Next one, after selecting, click on finish. Click on finish button thing. Click on finish button. So project is created. Step 2 is completed. Step 3. Step 3. Step 3, add required libraries. Required libraries in required dependencies. Dependencies in build.sbt. Build.sbt. Add required libraries in build.sbt. Spark core. Spark core. Spark hyphen core. Required. Spark hyphen core jar file. Spark hyphen SQL. Spark core required. Spark hyphen core jar file. Spark hyphen SQL required. Spark hyphen SQL jar file. Okay. So how to find Spark dependencies. Okay. How to find Spark dependencies. Okay. First one, open any web browser thing. Open any web browser. Let me minimize this IDE. Open any web browser. Okay. Search Spark hyphen core dependency. Spark hyphen core SBT. Click on this first link. In this again, go back to org.apache.spark. Okay. So here we are seeing Spark hyphen core. This is Spark core, Spark SQL. Okay. For every Spark hyphen high integration, Spark machine learning, Spark graphics, Spark Kafka. For all these, we can find dependencies here. First one, Spark hyphen core thing. Here we have different versions. Spark 3.x, Spark 2.x. Under Spark 2.x, I'm Spark 3.x, Spark 2.x supporting Scala 2.12. That's why while creating Spark project, we choose a Scala version 2.12. So I'm choosing 2.4.16. So I'm clicking on this one. So here we see Marvin dependency, Gradle dependency, SBT. We copy this one. So here, first one thing, Spark core dependency. Spark core dependency. Similar way, Spark SQL dependency. 2.4.6 to Scala 2.12. This is Spark core SQL dependency. Like this, you can find whatever the dependency you required. Okay. So for developing first example, I need only Spark core. Copy this dependency team. Copy this dependency. Go to our Spark application here. Go to expand this one. Click on this build.sbt. Here, enter this dependency team. Now click on refresh. Then it will start depending on downloading the dependency. So once we place, it will download the dependency automatically. Yep, it is downloaded successfully. So first one, step 3 is completed. Now step 4. Step 4. Step 4. Write Spark and Scala program. Spark and Scala program team. So we have already written some statements in interactive mode. Let's copy all those statements. So first one, we created RDD. This is our first statement. Yes or no? So here we follow some steps, team. First, in step 4, A, create a Scala class. Create a Scala class. So go to SRC, go to main. Here we see Scala. So first one, once we create a project, right? After step 2, once we create a project team, once we create project, so it will create a project structure like first. Under first, we are seeing SRC. We are going to see one more test. So here we are seeing SRT and build.sbt. We are seeing two files, build.sbt and others also. These two is important. Under SRC team, under SRC, again we are seeing one is main, one is test. Under SRC, again we are seeing main and test. Again under main, we are going to see Scala folder, and under test we are going to see Scala folder. Here we write star dot Scala, means Scala programs. Spark and Scala programs team. Spark and Scala programs. Below also we are going to write Spark and Scala programs. Spark and Scala programs, but these are unit test case classes. Unit test case classes. So these are written by programmer, not tester. Before going to hand over our application to tester, we will write unit test class. Okay. So create Scala class. Where we are going to create Scala class? Expand SRC main, right click on the Scala. Here we see new, here we see Scala class. Okay. In this we select object. Class name I am giving test. Class name, first class name I am giving test type. In this we will write one function def main. In this we are going to write statement. So first statement team. First statement, after creating a class, second import required packages. See, create create Spark context. Spark context. If you observe interactive mode, in interactive mode, Spark context is already created. No need to create. Whenever we start a Spark-cell, Spark context is already created. But in script mode, we have to create a Spark context. How can we create a Spark context? There are 3 steps to it. Creating Spark context. Creating Spark context. Creating Spark context. Okay. So here, first val conf equal to new Spark conf. Okay. It is showing red mark because we did not import. Place cursor here. So once again, this click on rebuild option. It may take few minutes and it will show. Once we create the Spark context, then conf.set. Let's wait you. Now place cursor in Spark. We are seeing import org.apache.spark.conf. Right? Now let's write conf.set application name. Application name I'm setting first Spark application. First Spark application thing. Next I'm setting conf.set master. Set master I'm setting local of starting. What is star? We are going to discuss later. Local of star. What is local? We are going to discuss it. After setting all these parameters, now val sc equal to new Spark context. Spark context. So alt enter. It is imported automatically. Spark context and conf. Now pass our configuration object. pass configuration object to Spark constructor, Spark context constructor. So first context is created. Now RDD creation, create RDD, create RDD. So in interactive mode, we created RDD, right? Let me take this step. By loading comment file, we are creating RDD. Now apply Spark operations. Spark operations. So let me copy previous steps. So we applied print count, println count. Okay. Next we printed all the rows of RDD. Yep. So let me write one more println some star values. Then again, after printing all the rows, I am printing star. Next, I want to print only 2 records from RDD. Yeah, that's a thing. So we developed a program. So as part of step 4, we developed a program team. So these are our steps. So we written all the programs, all these statements. Okay. After this team, step 5. Step 5. Run the program. Run the program. So right click on this program team. Right click on this program. Here we see run test. So it will read step by step and execute step by step and displays output here only. So it is providing IDE, providing development environment and runtime environment. Let's see team. Yep. So here we are going to see output with logs. We got output, but within logs. So this is output. 2 rows it is printed. It is printed 4 rows. And somewhere it is printed count also. Yes or no? Then here sc dot set log level. Set log level. I'm setting warning. I don't want to complete logs, only print warnings. Then once again run this program. You will see output after printing log. So our output not mixed with log thing. Let's see the output. So after printing all the warning logs, we are getting output. This is our output. Yes or no? So whatever we are expecting, it is printing same, right? T? Yes or no? So our file contains 4 rows. These are 4 rows. And we printed 4 rows. Again, we printed 2 rows. Okay. So this is the way to develop Spark and Scala application using script mode, using IDE. In script mode, We follow these 5 steps for developing script mode development. Okay. Any queries up to now, team? Hello, online team. Any queries up to now? Offline team? Yep. Okay. Now let's understand differences between interactive mode and script mode. We seen what is interactive mode and first example in interactive mode, and we seen what is script mode, first example in script mode. Now let's understand differences between interactive mode and script mode. First one thing, in interactive mode, we will develop statements step by step. We will develop statements step by step. Okay. In script mode, we will write all statements. In script mode, we will write all statements. In interactive mode, we will write step by step. This is first one. Next difference. In interactive mode, each step output we can see. Each step output we can see. But script mode, after complete development, we will run. In script mode, after writing all statements, we will use run button, then we will run script. So after complete development, we will run script. This is next difference. And third difference is in interactive mode, if there is any error, we can immediately resolve. But in script mode, until runtime, we do not know whether statements are correct or not. Whether statements are correct or not. So interactive mode, we will write each statement. When we press enter, based on output, we can guess whether statement is correct or not. Yes or no? But in script mode team, until runtime, we do not know whether all statements are correct or not. After running, we will check all the statements. So interactive mode is very good at development time, but script mode is not good at development time. Next important difference, interactive mode, 1 minute. Yep. In interactive mode, development time is slow. Development time is slow because each statement we will write, we will see the output. Next, we will write another statement. Again, we see the output. Then we will wait for output. Then we will, after output, again we will write the next statement. So in interactive mode, development is slow, but in script mode, development is faster. Development is faster because we will write all statements first. Later we will run. Yes or no? Interactive mode, step by step we write. Each step output we see. Until that output we have to wait. So development is slow. But in script mode, we will write all statements. Later we will run. So development is faster in script mode. Next, very, very important difference. Interactive mode used only in development. Only in development. Not in testing, and not in production. Not in testing, not in production. Why this interactive mode not used in testing, not used in production? Example, tester is ready. Tester is in remote location. Can we write statements in front of tester? Can we write statements in front of tester to test program? No. Client is ready. Client is ready to send a request. Can we write statements in front of a client? No. So that's why interactive mode not for testing, not for production. Script mode is for development, testing and production. Testing and production. So we seen in previous example, we seen script mode we written .scala program. In that .scala program we written Scala class. Yes or no? In that Scala class we run function, we return set of statements. We deploy that Scala script in server. So tester can test that .scala program, and the client can send a request to that .scala program. So script mode is for development, testing, production. Then immediately we have a question, which mode is preferred? Is it preferred interactive mode? Is it preferred script mode? Why interactive mode? If script mode preferred for all the environments, then why interactive mode? Previous session, if you observe, while writing Scala program, what I did, I copied interactive statements. Yes or no? I copied interactive statements. I prepared script mode application. If you observe previous two examples, interactive mode example and script mode example. First, coming to interactive mode. Advantage of interactive mode is each statement output we can see on a console, so that we can say whatever the statements we are writing correct or not. If there is any mistake, immediately we can correct it. Yes or no? Even though it is slow, but debugging is better compared to script mode. So first we will write the statements team. In interactive mode, we write the statements step by step. Later, we convert all valid statements into script mode. So development time, we use interactive mode, script mode. First, we will write statements in interactive mode. We convert all those interactive statements into script statements. Then finally, we deploy that script into test server and production server. Clear? So let's start. Scala for Spark. As part of Spark and Scala course, first we discussed Spark Foundation. Then we come to know importance of Scala language, right? So we understand, we written some programs in interactive mode and script mode, and we understand importance of Scala programming. Now we are learning Scala for Spark. As part of this one, first we are learning Scala Introduction. Scala Introduction team. So first one, Scala is a programming language. What kind of programming language it is? It is both functional oriented and object oriented programming language team. You can write pure functions or you can write a class and object. So it supports both functional oriented and object oriented programming. It was created by Martin Wodersky and it was introduced in Jan 20, 2014. It's not a new language. It was introduced in 2004. And very important thing, it is a JVM based language. Once we write the Scala programs, to run that Scala programs, JVM is required thing. JVM stands for Java Virtual Machine. Java Virtual Machine. It is a JVM based language. Let me discuss diagrammatically. So here we have 100+ languages which runs on top of JVM team. JVM stands for Java Virtual Machine. Java Virtual Machine. So JVM stands for Java Virtual Machine. There are 100+ languages available in the market. 100+ languages available in the market which runs on top of JVM. Example, Java applications, Java. Okay. Next one, Scala. There are plenty of languages available in the marketing. There are plenty of languages, around 100+ languages available in the market, which runs on top of JVM. So once we write a Scala program team, to run that Scala program, we require JVM, Java Virtual Machine. Okay. So it's a JVM based language. It's both functional, means procedure oriented, and object oriented programming language. It was implemented by Martin Wadersky in the year 2004, released in the year 2004. Let's understand advantages of Scala. Scala language, Scala is a both functional and object-oriented programming language. Object-oriented programming language. First one, it's a both procedure and object-oriented programming. First important advantage. Next one, it is easy to learn and easy to implement because its syntax is simple. Its syntax is simple. So learning and implementing Scala programs is very easy thing because its syntax is very simple. And next important advantage thing, it runs on JVM. It runs on JVM, Java Virtual Machine. It runs on Java Virtual Machine. Okay, and its syntax is similar to, not 100%, similar to Java syntax. So who are coming from Java background, they can easily learn, they can easily implement. They can easily learn, they can easily implement Scala applications. Next one, new users also easily learn, easily implement because its syntax is very simple. It reduces lot of lengthy code team. It provides lot of predefined functionalities. Compared to Java programming, Scala reduces lot of lengthy code team. It provides a lot of inbuilt features. So by using that inbuilt features, we can reduce a lot of lengthy code. Later, while writing Scala applications, while writing Spark and Scala applications, we will clearly understand the advantage of Scala programming. Okay. Syntax is simple, easy to implement, easy to learn. It's similar to Java syntax, so any Java programmer easily understand, easily implement. I said Scala is a JVM based language. Let's say you know complete Java syntax. Assume you are a Java programmer. You know complete Java syntax. Then you can write Java program. You can say .java .scala, it will work. But you cannot save Scala program as .java. Scala can understand Java program because Scala language is implemented using Java. Scala compiler is implemented using Java. So Scala compiler can understand Scala syntax as well as Java syntax. But Java compiler can understand only Java syntax. Okay. And development is faster. Development is faster compared to Java. Development is faster because lot of inbuilt APIs, lot of inbuilt APIs. Inbuilt APIs. API means application programming interface. Means predefined classes, predefined functions. It will provide a lot of inbuilt APIs. So development is very faster. So no need to write from scratch. They provide a lot of inbuilt APIs. And plenty of frameworks implemented, plenty of popular frameworks are implemented using Scala, like Akka framework, Play framework, Akka framework, Play framework, and Spark framework, Kafka framework. Plenty of frameworks available in the market. Plenty of popular frameworks are available in the market. Scala is not a new language. Scala is not a normal language. It's a very powerful. Plenty of applications are implementing using Scala language. Scala language can be used to develop these kind of language frameworks, and we can develop applications using Scala, desktop applications, multi-threaded applications, network-based applications, frameworks, editors, testing frameworks. Plenty of things we can do, we can develop by using Scala language. It's a powerful language. Lot of projects are implementing using Scala. It's a very powerful language. Because of Java kind of syntax, and it will run on JVM. Many people working, implementing Scala based applications, Scala framework based applications. We are seeing very popular nowadays Spark. Spark is very popular, yes or no? So many people getting jobs, many people are working on Spark. Many people are working on Kafka. As a big data developer, we know Spark and Kafka. We don't know Akka, we don't know Play. Plenty of applications are running on developing using Akka and Play framework team. It's not a simple language. It's very powerful and very popular frameworks. These are application frameworks. Some testing frameworks also implemented. Okay. So plenty of advantages are there. These are some important advantages. Let's see Scala installation. So Scala installation we already seen in Spark Foundation. We already discussed how to install Scala. Yes or no? Think we already discussed Scala installation in Spark Foundation. So downloaded Scala, installed Scala, we set Scala_home and path variable. Yes or no? We verified Scala is installed or not. So we've opened command prompt. Let's open command prompt. Type Scala space -- version. It will display Scala latest version. Scala latest version is 2.13.3. So this is latest version. Okay. So refer Spark Foundation class team. We have already discussed how to install Scala. Then how to start Scala. How to start Scala. So we can use we can type command Scala. You can type command Scala. It will start a Scala team. It will start a Scala. See? So Scala, it is started Scala, opened Scala prompt. It will start a Scala. So open command prompt and type Scala. Okay. It will start a Scala. It will start Scala and opens Scala prompt. Opens Scala prompt. So it will open Scala prompt. So this is Scala prompt. Important to notice. Important to note. So before going to install Scala, Java 8 should be installed. Okay. So Java should be installed. So we have already installed Java. We have already installed Scala. Then we started Scala prompt. Okay, team. Now let's understand Scala programming introduction. Scala programming introduction team. In Scala, we can develop applications. We can develop applications in first one interactive mode, and the second one script mode. We develop applications in interactive mode and script mode. We already seen what is interactive mode and what is script mode as part of Spark, right? So same way we can develop applications in interactive mode and script mode. So first one, let me explain interactive mode. In interactive mode, first, how to start interactive mode? How to start interactive mode? How to start interactive mode? So here team, first one, open command prompt. Open command prompt, type Scala. So when you type Scala, what it will do? It will start a Scala and it will open Scala prompt. Yes or no? It will open Scala prompt. This is called interactive mode. So when you open command prompt, when you type Scala, it will start what? It will start interactive mode. Interactive mode. This mode is called interactive mode. Okay. So here, so this interactive mode also called interactive mode also called REPL cell. Interactive mode cell also called REPL cell. REPL means R means read, E means evaluate, and P means print, and L means loop back. Loop back to same cell. Loop back to same cell. REPL means read, evaluate, print, and loop back to same cell. let me write some examples. When I say 10, 10 is a statement. It will read this statement, evaluates these statements. If it is an expression, it evaluates and prints on a console, and again it come back to same Scala prompt. 10 plus 20. Finally, result is 30. 10 minus 5. 10 minus 5. Result is 5. So it is reading 10-5 and evaluating that expression, printing on a console, and loop back to same cell. That's why we are calling REPL cell. REPL cell thing. Okay. So this cell we are calling REPL cell. Okay. Clear? Next one, script mode. Script mode in Scala. Script mode development in Scala. Scala programming as part of Scala programming team. As part of Scala programming, we are understanding first one interactive mode, second one script mode. So script mode team, we can develop Scala applications. We can develop Scala applications using editors like using editors like Notepad, Notepad++, etc. in Windows. Vim, VIE, gedit, Nano in Linux team. In Linux. Okay. So script mode in Scala we develop using editors like Notepad, Notepad++ in Windows, and Vim, VI, gedit, Nano in Linux environment, Linux or Unix environment. Okay. So IDEs, we can use editors or IDEs. IDEs, we have IntelliJ IDE, and we use Eclipse IDE, we use Scala IDE. There are a lot of IDEs. Okay. So first let's see first example using IDE software. First example using IDE software team. So first one, start IntelliJ. Create new project. Create new project. Next one, create new project. Here Scala, select Scala SBT. Give a name team. Give a name. First. Give a name. Then remaining options, choose default. Go to IntelliJ IDE. Double click on this IntelliJ IDE. So now let's go to File, New. Here we click on Project thing. File, New, Project. Click on Project. File, New Project. Select Scala. Select Scala SBT. Click on Next. Here, select the location. Click on this Browse button. So I want to create Scala project. So under Scala, I'm creating a folder first. Click on OK. So click on OK. Then leave all options of default. Click on Finish. I want to open in this window. So first it is created Scala project. Scala project. So project name is first. In this first, it will create importantly one important folder, SRC folder. Under SRC we see two folders. Under SRC we see two folders. One is main and another one is test. In both location we see Scala. In both location we see Scala. Under test, under main, we see folder is Scala. Let me open main, expand test, we see Scala. Here we write Scala program setting, dot Scala scripts, start dot Scala scripts. So these are application scripts. And here also we write dot Scala programs, but these programs are unit test cases. Start dot Scala. Here we write unit test cases. So this is Scala project structure team. Scala project structure. Let me write Scala project structure. Yeah. Okay. Now let's write a simple class. So let me right click on this main. Under main we have a Scala. Right click on this Scala. Click on new. Let's write it. If you observe below right side, it is processing. Once it is processing is completed, it will show Scala classes. Okay, let's wait. Now let's continue team. So here project structure is successfully created. Right click on Scala, click on new. Here we are seeing Java class, Scala class, Kotlin and etc. We want to create Scala class. If you observe here, first let me, after creating this structure, create a Scala class. Create a Scala class. Scala class. Here we are seeing mainly three classes stream. One is class, case class, object. These are main important one. Additionally, they introduced case object trait. Class, case class, object trait. Recently they introduced case object. Okay. So select object. Why we are selecting object, we are going to discuss in depth. No worries. So first one, select object, give a name. I am giving test. Class name I am giving test. So it is created one class called test. In this we write def main present. Here we will write println welcome to Scala world. Welcome to Scala world team. So once we develop this application, we will run this program team. Run the Scala program. Run the Scala. So right click, run test. It will execute statements, all statements are presented in def main function and writes output in a console. Let's wait till observe the output. So welcome to Scala world. So we got output. So this is our output. So understand, right? In interactive mode, we write the statements in a console. This is our console. In script mode, we write programs in a editor or IDE software. IDE software provides a lot of advantages. So it is highly recommended to use IDE software for developing Scala or Scala based frameworks. Scala or Scala based framework applications team. Okay. So understand, right? Now let's understand Scala variables. There are two types of variables team. There are two types of variables in Scala. They are first one val type, second one var type. First one val type, second one var type type. First, let's understand val. What is val? Let's practically see val a equal to 10, val b equal to 10.5, val c equal to C family. Okay, val grade equal to A, val d equal to true. Val d equal to true thing. So we created multiple variables. So first one, by using val, we can create variables. By using val, we can store different kind of data. So val keyword can be used to declare variables. First one, val keyword can be used to declare variables. It can accept any type of data. It can be used to declare any type of variables. Maybe numeric variables, maybe floating point variables, maybe string variables, maybe character variables, maybe Boolean variables. So by using val, we can declare variables team. It may be any type. First important point. Next one. Next very important point. Let's take example 2. So I'm declaring val a equal to 10 team. So print a. I'm printing a value. So we got output is 10. Again, a equal to I am trying to reassign value 20. It is giving error saying reassignment to value not possible. Reassignment to value a is not possible. Let me copy this example. If you declare any variable with val type, if you declare any variable with val type, we cannot change the values. We cannot change the value. We cannot change the value of type. We cannot change the value. These are fixed variables. These are fixed variables team. During the program, we cannot change the value of that variable. Those are fixed variables. Example, this one. So we are trying to reassign value 20 to variable a. We got error saying reassignment to val. Okay. Next one thing, var type. So similar way, var keyword can be used to declare variables. It can be used to declare any type of variables. So var a equal to 10, var b equal to 10.5, var c equal to C family, var d equal to A grade, var e equal to true. So by using var or val, we can declare any type of variable string. First important point, by using val or var, we can declare any type of variables. Second example team, var variables where variable values can be changeable. During the program runtime, you can change value. We can change the value of var variable. These are not fixed variables. These are not a fixed variables team. During the program, during the runtime of your program, you can change value. Let's see example. Where a equal to 10. I am printing a value. Later, I am changing a equal to 20. Then print a. Now we are getting new value. So variable a is mutable. Previously immutable. Now it is mutable because of var type team. Because of var type, we can change a value. We can change a value team. Clear? So differences between var type, clear, right team? Yeah. So now, yep. Let's start. In this session, we are going to discuss Scala data types. First, let's understand what is data type. What is data type? So data type means data types are used to allocate sufficient memory, allocate sufficient memory for user inputs. Example team, we are writing application, Scala application. For Scala application, user may pass numeric value, user may pass floating point value, user may pass string values, user may pass boolean value, user may pass character values, user may pass group of values, right? So user may pass different kind of inputs. So let's say user may pass numeric value, user may pass floating point value, user may pass group of characters, user may pass single character, user may pass boolean values, user may pass list of values, user may pass list of values too. So user pass different kind of inputs to application. So this is our Scala application. So for each input, these are inputs. These are different inputs. We want to allocate sufficient memory in a RAM. Temporarily, to store this data in a memory, we want to allocate sufficient memory for every user input. On that input, we apply processing. Yes or no? So to allocate sufficient memory for every user input, we use data types team. Data types are used for allocating sufficient memory for user inputs in a memory. First important point. Okay. So there are two types of data types. There are two types of data types. They are one, simple data types. Simple data types team. It stores only one value at a time. Only one value at a time. It stores only one value at a time. Second one, complex or collection data types. Complex or collection data types. It stores multiple values. It stores multiple values. Multiple values at a time. Multiple values at a time team. So it stores multiple values at a time. So data types are used to allocate sufficient memory for every user input. We have two types of data types, simple data types and complex data types. And next very, very important point about data types in Scala is every data type is a predefined class. Every data type is a predefined class. There is no concept of primitive in Scala. Everything is a class and object type. Even functions also objects in Scala. I will clearly explain at the time of functions discussion. Functional oriented concept discussion. I will clearly explain why functions I am saying object. Okay. So everything is a class and object concept in Scala. It's a pure object oriented language string. There is no primitive concept. Every data type is a predefined class. It may be simple data type, it may be collection data type. Every data type is a predefined class. Now let's start a simple data type setting. So what are simple data types? Simple data types stores only one value at a time. One value at a time. So simple data types stores only one value at a time. First important thing. Second one, every simple data type is a predefined class. Every simple data type is a predefined class. For every Java data type, we have an equivalent data type in Scala. equivalent data type in Scala. So why we are comparing Java here? Why Java comes into picture here is because finally our Scala programs are going to run on what? Run on JVM. So JVM has to understand our data type classes. Yes or no? That's why I'm comparing here. So for every Java data type, we have an equivalent data type in Scala. So we have byte class, we have short class, we have int class, we have long class, we have float class, we have double class, we have string class, we have char class, we have boolean class. So these are different predefined classes for data types. These are different predefined classes. And next very important point. It is not mandatory. It is not mandatory to specify type. To specify type at the time of variable declaration. Specify type at the time of variable declaration. Variables declaration. Yep. It is not mandatory to specify the type at the time of variable declaration. Scala automatically recognizes. Scala automatically recognizes type based on right side value and it assigns a type to variable type. Let's take some simple example. Start command prompt and let's start a Scala. Let's start a Scala team. So first I am declaring val a equal to 10. Observing here I did not declare any variable type, but based on right side value, Scala based on right side value, it will assign type to variable a. So here it will assign type automatically to variable a is into type. Let's observe. Below you are seeing value a equal to int. Are you observing thing? Based on the right side value, it is assigned. Val b equal to, I am assigning 10.5. Based on the right side value, it will assign type to variable b. B type is here double. Val c equal to, I am storing C family. It is assigned string. Next, val d equal to, I am assigning single quote a. Observe, it is assigned char type. Val e equal to true. It is assigned Boolean type. Yes or no? Based on the right side value, it will automatically assign a type to variables in Scala. And next, we can find the class name using one predefined class called get class. So a dot get class is a predefined function presented in all classes. It will return class name. So class int. Then I'm printing all variables class name to b dot class. Class name is double. C dot class Here it will display class name is string and D dot class. D class name is char. Now let's display E dot class. E dot class name is boolean. Yes or no? Are you observing, team? Let me copy all this code. Let's enter here. So these are different examples for data types team. Okay. So let me write here. So get class function. Get class function. It is a predefined function. It is a predefined function presented in all classes, and it returns class name. It returns class name too. So we are getting variable A class name is class int. Variable B class name is class double. Variable C class name is java.lang.string. Variable D class name is char. Variable E class name is boolean. Clear? Clear team? So variables defining type is optional. So one more important point I am covering here. Defining type is optional. Defining type is optional. Type is optional. We can also define type. Let me write defining type. Val a colon. How to define a type? Val a colon int equal to 10. Yeah. So now val b equal to b colon float equal to 10.5. Okay. So we have to use f. By default, every floating point is double type. That's why we got an error. Next one, val c equal to c colon string equal to C family. Val D colon char equal to single quote A grade. Next, val E colon boolean. E colon boolean equal to true. So like this we can define type. Let me. Question is how to define type. How to define type. How to define type. These are different examples. Here I am writing one note, one important note. By default, every numeric value is int type. Okay. So let's write here. By default, every floating point value is double type in Scala type. That's why we added f. Okay, so clear, right? We can add a type, but it is optional. Based on the right side value, Scala automatically recognizing a type. Scala automatically recognizing a type. So no need to pass, no need to specify data type at the time of variable declaration. Okay. So one more problem with variable declaration, type declaration thing. Let's say val a colon int. When I say type val a equal to 10, when I try to assign 10.5, it will give left and right. Why it will give left and right? Because right side you are saying floating point value, left side you declare variable a equal to int type. Instead, if you remove type, you can assign any value, right? Yes or no? So if you define type, you have to pass the same type of value. You have to pass the same type of value. So that's why we always declare a variable without a type. Scala will automatically recognize a type and assigns a type to variable type. Okay, this is one more important point. Let me write this example. If you define a type, if you define a type, we have to assign same type of same type of same type of values same type of values. Example, this is one example. Okay, yeah, so that's it for simple data types. Okay, simple data types. Now let's understand Scala typecasting. So first, typecasting means converting data type from converting value from one data type to another data type, one data type to another data type. Converting value from one data type to another data type is called Scala typecasting tip. There are two types of typecasting. There are two types of typecasting. There are two types of typecasting. One, implicit typecasting, and second one, explicit typecasting. Implicit typecasting and explicit typecasting. There are two types of typecastings: implicit typecasting and explicit typecasting. So first let's understand implicit typecasting. Implicit typecasting. Implicit typecasting thing. Scala performs implicit typecasting automatically. Scala performs implicit typecasting automatically. Implicit typecasting automatically. When it performs implicit typecasting, when we assign lower data type, data type to lower data type to higher data type. Higher data type. Whenever you are trying to convert lower data type to higher data type, then Scala will perform implicit typecasting. Let's understand byte to short, byte and short to int, byte short int to long, byte short long to float, byte short long float to double. In this case, it will perform implicit typecasting. Another one, char to int or char to float or char to any other. Char to int or char to long, char to float, char to double. In this case also it will perform implicit typecasting team. Implicit typecasting. Let's see some practical examples so that we will confirm whether Scala performs implicit typecasting or not. Okay. So I'm taking val a colon byte equal to 10. I'm assigning value 10 team. Val b colon char equal to grade A. Sorry, grade A. Capital A grade value is 65. Hash key value is 65. Unicode value also 65. Okay. So what I'm doing, I'm declaring a variable val c colon float equal to, I'm assigning A. It is converted. A type is byte. It is converted. Val c colon int equal to A. It is converted. Val c colon float equal to, I am converting B. 65.0. Val c colon int equal to B. It is converted. Clear? Val c colon double equal to B. Val c colon double equal to A. It is converted. Yes or no? So whenever you are trying to assign lower data type to higher data type, Scala will take care and converts lower data type value to higher data type value automatically. This process we are calling implicit typecasting. Okay. So let me copy this one. Let me copy this example. Now, explicit typecasting. Explicit typecasting. Explicit typecasting performed by programmer, not Scala. When explicit typecasting performed, when we are trying to assign higher data type value to lower data type value, lower data type. So same reverse thing, same thing reverse. whenever you want to assign double value to float or double and float value to long, double and float value to long, double float long value to integer, and double float long int value to short, double float long int char to short, double float long int char short to byte. Then reverse operation we have to perform whenever you are trying to typecast a higher data type value to lower data type variable, then we have to perform explicit typecasting. Explicit typecasting thing. Clear? So let's see examples. Let's see example stream. So I have a val a equal to val a colon, let's say double equal to 10.5. I'm trying to assign val b colon int equal to a. It will give left and right. It is saying type mismatch. Hey Srinivas, you are trying to assign double but required integer. It's clearly giving error message saying, hey Srinivas, you are trying to assign double, but it requires or expecting integer. Then what we can do here? Here we have to perform typecasting. We have to perform typecasting. How to perform typecasting? Let's take this one. Here we got an error. So how to perform typecasting? How to perform typecasting? Explicit typecasting. How to perform explicit typecasting thing? Let's observe first approach. First approach thing. Here I am converting int of a. So it is giving error saying value a is not a member of int. Value a is not member of int. So we got an error. First one, we got an error. Then how can we perform typecasting? Then how can we perform? We perform typecasting. In other languages, we do this approach too. We do above approach, this example approach, but it is giving error. Then how can we do typecasting? For every data type, for every data type class, Scala given different functions. Scala given different functions to convert. Okay, let's see example. So first one, let's say team val b colon int a dot to int function val b colon float, float, to float, to float function, val b equal to long, long, to long function, to long function, val b colon short, to short function, to short function, val b equal to byte, to short, sorry, byte, 2 byte function, 2 byte function. Clear? So every data type class, every data type class has these functions thing. Sorry. Every data type class has all these functions. Every data type class has these functions. It may be byte class, it may be int class, it may be long class, it may be short class, it may be float class, it may be double class, it may be char class. All classes contain typecasting functions. Typecasting functions. No need to perform explicit typecasting. You like previous languages approach like this. Every class contains these predefined functions team. These predefined functions. You can convert one form to other form. One form to other form. So this is explicit typecasting. Any queries up to? Yep. In previous session, we seen simple data types in Scala. Next, we seen typecasting in Scala. Now let's see, as part of simple data types, let's see Scala string. String is a predefined class. String is a predefined class. It's a predefined class. String means what? String is a collection of characters. String is a collection of characters or group of characters. Collection of characters or group of character. Collection or group. Group of characters. In Scala, every string enclosed within double quote. In Scala, every string enclosed within double quoting. Every string enclosed within double quotes. Let's see some open command prompt. Let's start the Scala. Let's see some examples related to string team. So first one, I am writing println statement. Inside a println statement, I am writing string message. Welcome to Scala world. Welcome to Scala world. So here we are displaying this string message on a console. Println is a predefined function. It will display message on a console. Yes or no? Next one, I'm writing some message inside double quotes. I'm writing message C family. When I type C family, it creating one variable, and in that variable it is assigning C family and displaying on a console. Now let's say println result 1. So if you not assign any value, it will assign some predefined variables. Variable names starts with res 0, 1, 2, 3, 4, 5, like that thing. Okay, so every string enclosed within double quote. Every string enclosed within double quote. If you not assign any variable, it will take default variable. Default variable name starts with res, and first variable 1, second variable 2, 3, 4, 5, like that it will create multiple default variables. We can also assign value to variable. Let's say val name equal to inside this one C family. And I said one more important point, specifying data type is optional. Yes or no? Specifying data type is optional. By default, whenever we put any string in double quote, by default Scala understands it is a string. Then left side we have a variable name. So that variable type automatically defined by Scala. Okay. So if you want to know whether that variable is string class or not, then use name dot get class. In previous session, we understand get class function. Get class function returns the class name of that variable. So it is returning class name is string. It is a child class of java.lang.stringu class. Scala stringu class is a child class of java.lang.string. Okay, so I'm taking one more variable thing. So val name equal to, let's say I'm taking Srinivas, and other name taking val last name equal to Akim. So I'm taking two variables string. I'm adding new variable val full name equal to name plus last name. Then println full name. Println full name too. Full name is a variable. We are getting Srinivas Akim. Let's say this variable, let me copy these examples. So these are different examples. So last example team here, let me give space here so that we get Srinivas space Akim. Okay. Okay. So here, if you observe here, plus operator here working as a concatenation operator thing. So whenever we perform this plus operation, what will happen? First, we have two variables. One variable name is name, another variable name is L name. So first variable contain data Srinivas. Second variable contain data. Okay. Yes, sir. We have two variables. So this is name and this is last name. Last name. Here we are using plus operator. Plus operator. Whenever we use name plus last name, it will not update data into name variable. It will not update data into last name variable. It will create a new memory. New memory. In this memory, it will update data saying Srinivas space active. So this new variable is pointing by full name variable. Full name variable. So understand, right, team? So here we have three variables. Three variables are pointing different memory locations. Name variable pointing different memory location. Last name variable pointing different memory location. When we use plus operator, it is concatenating, creating new memory. Creating new memory. Okay. So one more example. Let's say I have variable val name equal to let's say C family. I taken variable name variable name is name and value is C family. Okay. Here I'm printing as it is. So I'm using variable name. So print or println, you can take any function. So I'm using print or println function. It is executed variable name and printed variable value. Okay. So one more print. I want to print a message along with the name. I want to print a message saying institute or company. Company name. So here I want to print this variable value. So when I use this one, it is giving company name colon C family. This is one way. Another way, if I use variable inside this double quote, if I use variable inside this double quote, what will happen? So this name in our view, it is a variable name. It has to execute and replace name with C family. But we got output is name colon name, company name colon name. But our requirement is inside a double quotes, we may put variable names. If any variables inside a double quote, it has to execute and replace variable with value. That is our requirement. For that one, there is one substitution variable called $. For any variable inside a double quote, if you want to replace that variable with value, we substitute with $. Then that variable replace with value. Still it is not displaying. Then we have to indicate a Spark saying, Scala saying a Scala in this double quotes, it may contain multiple variables. So replace variables with values by suffixing s to string. Then observing name variable replaced with its value. Clear? So this is one more important point related to string routing. Next important one, string handling functions. String handling functions. So we have different string handling functions. We have different string handling functions. Let's say I'm taking variable name equal to, I'm providing name is C family. I want to know length of this variable value. So we can use predefined function name dot length. Length is a predefined function presented in string class. It is returning number of characters in that string, 7 characters. 7 character string. There is one more function, size function. Size function also returns same thing. Length and size functions returns size of the string variable. Size of the string variable thing. There is one function, substring function. Let's say name dot substring, name dot substring. My requirement is from first character, means after C. I want 1 to 7. I want 1 to 7. Let's see. We got output is family. I want to milli, MILY. So this is 0, 1, 2, 3. 3 to 7. We can use substring 3 to 7. We got milli. So substring function, we can read data from string from particular character to particular character. Let's say I want 1 to 4. 1 to 4. I got MY, FAMY, FAM, 0, 1, 1 to 2, 3. 4 means this 1 is included, 4 is excluded. So substring returns values between starting string to end string. And there is one more function team, take function. Name dot take function. And how many characters you want to read from string? Let's say I want to read first 2 characters, CF. I want to read first 4 characters, CFAM. So take function returns number of characters string. And there is one more function, to upper function. To upper function. It will to uppercase. It will convert lowercase characters to uppercase characters. Then to lower case. See team, I am saying these are predefined functions. Take, substring, length, size, take, to uppercase, to lowercase, substring. I am saying all these are functions. If you observe above syntaxes, some functions I am using bracket, some functions I am not using any parenthesis. Yes or no? So remember one important point to team. If function not takes any argument, providing parenthesis is optional in Scala. Providing parenthesis is optional in Scala team. It's not mandatory. Okay. So it will convert uppercase to lowercase team. There is one more important function called slice function. There is one more important function called slice function team. Slice function also works like substring. Let's say 0, 3. From 0 between 3. 0 index, first index, second index you will get. It is like a substring. And there are some important pattern matching functions to team. There are some important pattern matching functions. So we have two functions to team, pattern matching functions. So Stingo class has pattern matching functions. Pattern matching functions. What are pattern matching functions available in Stingo class? We are going to use these pattern matching functions whenever we want to read particular data presented in input data or not. Let's say we are getting multiple lines. Each line we want to verify whether each row contain our required input or not. If data contain our required input, then only we can read that row. Otherwise, we want to ignore. So for that one, we use pattern matching functions. Pattern matching functions. First one contains a function team. First one contains function. Let me write one variable val comment. I am writing Scala is a language. Scala is a language. This is my comment variable. We have one function called contains function. So first one contains function. Contains function. So it will find the string. It will find the required string. It will find the required string in source. Example, let's take example. My requirement is comment dot contains. Comments dot contains Scala. Is Scala presented in our target string? Yes, it is written Boolean value t, true. Scala contains Java, no. So we got output is Boolean value is false. So if target string target string presented in actual string, it will return true. Otherwise, it will return false. Other example team. Other example or other pattern matching function. There is one more pattern matching function, matches function thing, matches function. This matches function compares entire target string. So it will compare. So this matches function compares string, compares specified string with actual string. It compares specified string to actual string. Specified string to actual string. Let's say we have a comment string. Here I want to search comment dot matches, and I am searching Scala. It will give false because this Scala compares with entire comment string. It is not matched with entire comments string. When it will return true? Whenever you pass this entire string in a matches. So both are matched, it will return true. So our specified string compares with target string with the entire value. Entire value matches, then only it will return true. Otherwise, it will return falsity. So this is one of the important two functions. Important two functions. We use these functions in our string comparisons. Example, we are reading file. In file, we are reading each row. Each row, we want to compare with the target string, or in each row, we want to find our required string is available or not. If you want to find the required string is available or not, we use contains function. If you want to compare entire row with our required specified string, then we use matches function. So these are important functions. These are important functions. Let's start it. Scala complex data types are collection data types. It allows multiple values. It allows multiple values in a single variable. It allows multiple values in a single variable. So simple data types allows only one value at a time, but complex data types allows multiple values at a time. It allows multiple values at a time too. There are many collection data types in Scala. There are many collection data types in Scala. In that we are discussing some important collection data types. Some important collection data types. We are not discussing all data types. We are discussing some important data types. First one is arrays. Second one is tuple. And the third one is third one is list, fourth one is set, and fifth one map. We are going to discuss these 5 important collection data types. There are many collection data types. As part of our Scala for Spark, we are discussing these 5 important data types. Because in our Spark programming, sometimes we will create RDDs or data frames by converting local collection into Spark RDD or data frame T. So that time we have to know what are different local collection data types are available and how to create it and how to convert these things to Spark RDDs. Okay, so these are very important data types, collection data types. In this, first let's understand arrays. In complex or collection data types, first let's understand arrays. So first, what is array? Array is a collection or group of elements of same type. Means homogeneous elements. Team. Collection of or group of homogeneous elements. Arrays are classes in Scala. Classes in Scala. And every time I am saying Scala, everything is a class and object. That's why Scala is a pure object-oriented programming language. In Java, some people, because of primitive data types, some people says Java is not pure object-oriented language, but in Scala, everything is class and object. So Scala is a pure object-oriented programming language. We will discuss that one, what is object-oriented and what are important features later. Okay. So first, arrays are classes in Scala. And next, very important thing, array is immutable collection in Scala. Array is a immutable collection in Scala. What is immutability here? Here, immutability means immutability means size is not changeable. Once we declare array with some size, we cannot increase, we cannot decrease it. We cannot increase, we cannot decrease. So this is called immutability in arrays. Other concepts, immutability means different. In arrays, immutability means size we cannot increase, we cannot decrease once we specify. Okay. So let me take array. Let me take one array. So first I am creating array team. Let me take some examples related to array. Val name colon names colon array of strings. I'm declaring array of string. Then what I'm doing, this array I'm saying new array, and type I'm specifying string. First I'm specifying what type of data I'm going to store in this array. Then I'm saying size I want to 10 memory locations. This is my requirement. Sorry, one letter we added here. Now let's execute. So it is created an array. 10 memory locations are allocated. In all 10 memory locations, default it is stored null values. If you observe here, by default in 10 memory locations, it is assigned array with null values. Yes or no? So first one, array with the default value. The first example is array with the default value. Array with default value. First example we seen array with the default value. Next example, let's see it. Next example, inserting array. Inserting array. So we can insert arrays using index. Here I will write one important note. Every array we can access by using index team. Index starts from 0. Index starts from 0 and ends with n minus 1. N is the size of the array. Okay. So let me insert array. So I'm inserting array. Names of 0 equal to C family. Names of 1 equal to Srinivas. Sri. Names of 2 equal to Nivas. Names of 3 equal to Swati. Names of 4 equal to Meena. Names of 5 equal to, let's say, Akim. So names of 5. We inserted some value string. So this is inserting data into string by using index. So index starts with 0. So we used this syntax for, we use this syntax using index, we inserted data type. So for next one, accessing array elements. So we can access array elements by using index type. Let's see, print control L. Let's say print ln names of 0, println names of 1, println names of 2, println names of 3, println names of 4. So by using index we can access string. By using index we can access names of 6. So we didn't store, it has 0, sorry, null value. This is way 1. Way 1. We can use index to access the data. Way 2, we can use for or while loops to access string data. Sorry, access array data. It is recommended thing. It is recommended. Way 2 is recommended. So we can use way 2 team. So I'm writing for I implies 0 until names dot length. Sorry, this is 0 team. 0 until names dot length. Okay, so here we can write println let's say curly braces start println names of I, then close for. So we can use for loop team. It is recommended. This approach is recommended. So to read data from arrays, this approach is recommended team. We always use for loop for iterating arrays team. In arrays also, here also we have under way we have a. This is for 0 until names dot length. So this is normal for loop. And we have a for each loop team. Second approach, for each loop. It is recommended. See the for each loop syntax team. See for each loop syntax. Same for name implies names. Name implies names. Bracket start and println name. That's it. Println name. Close for. See, for each loop, first it will take first element stores in name. We are printing. Next it will take next element and stores in name. So 10 times this for loop repeats automatically. So this approach is recommended. This approach is recommended. For each is recommended because syntax is very simple compared to previous for loop. For each loop syntax is simple. That's why it is highly recommended. Highly recommended. Yeah, team. In previous session, discussed arrays in Scala, Scala arrays. So first we discussed what is array, what is an array. Next one we discussed how to create an array, creating array. So in this way we created array. And next one we discussed how to insert an array. Next we discussed accessing array elements. So way one by using index. And next one way to using for loop or while loop. In that again, for loop we can use two ways. Normal for loop and next one for each. So for each is recommended. Yes or no? So we seen creating array by using this syntax. So we used new operator. I said every array is a predefined class in Scala. So to create array object, we use new operator. This is one. And we have some predefined classes team. Predefined classes and functions. So there is one function called range. There is one function called range. And we have one predefined class called range class. So next way, range. So by using range class object, we can create an array. But this is numeric array. We can create numeric array. So let's understand by using range object, range constructor object, or range object, we can create an array. We can create an array with range of values, with range of values team, range of values. Let's understand simple example. By writing simple example, let me open command program. Let's start Scala. Let me create a variable with a range of values. Let's create a variable with a range of values. I'm creating val nums equal to, I'm creating range object. Here I'm specifying start value and end value. So it will create a range of values from 0 between 10. 0 between 10 mean 10 thing. So 0 is included, 10 is excluded. Here 0 is included, 10 is excluded team. Now I want to print the values. For I implies nums. Bracket start, print I. Close bracket. Let's say it. So it is printing 1 to 9 numbers, but here above syntax I used print function. That's why it is printed all values in a single row. Now let's observe, we got values 1 to 10. Yes or no? 1 to 9, sorry, 0 to 9. So range is a predefined class. So here we are creating range of values by using this functionality. Let me copy this one and let's write. This is other way to create range of value string. And next, very important one, mutable array. Mutable array. I said by default every arrays are immutable. I said by default every array is a immutable. Immutable means once we create an array with size we cannot increase, we cannot decrease. Size we cannot increase and size we cannot decrease string. Yes or no? But what about mutable array? Mutable arrays size is increased dynamically. Mutable array means mutable array means dynamically it increase the size. Dynamically it increase the size. It increase the size. What is the meaning of dynamically it increase the size? So we create an array object without any size. Let's say you keep on adding elements into array. We keep on adding elements into array. It will increase or grows size automatically. Depends upon the elements you are adding to mutable array type. Mutable array. So for mutable array, they given one predefined class called array buffer class. Array buffer class. Array buffer class is a mutable array class. Mutable array class team. It is a mutable array class. Let's create a array buffer class object and let's add elements into that. Let's create array buffer class object. Then let's try to add elements into that. Okay. So let me try to create variable val let's say fruits equal to new array buffer. I'm creating an objective. So in this array buffer, we want to store all string objects. So I'm specifying the type. Okay, let's execute this one. Here we got an array. We got an array error saying type array buffer, not found type array buffer. Let me copy this syntax. Let me copy this syntax string. So we are getting error saying not found type array buffer. One important note here. One important note. All mutable classes. It may be array buffer. It may be any other mutable class. All mutable classes present in present in package Scala dot collection mutable package Scala dot collection dot mutable packaged in Scala dot mutable package. So we have to import this package. We have to import this package. So we can import two syntaxes string. We can import Scala dot collection dot mutable dot underscore means all classes of this package. I want only array buffer. Then use import Scala dot collection dot mutable dot this is mutable. So mutable dot array buffer thing. In this way we can import array buffer class. Then we cannot get any error. Once you import this package, then you can create an object of array buffer. Now we did not get any error. So we create an array buffer class without any size. Yes or no? Without any size. Then we can add elements to this array buffer. We can add elements to this array buffer dynamically. Now I am adding array buffer class. Now let's add elements string. I am adding fruits plus equal to I am adding element apple. Let's say I am adding different fruit, mango. I am adding banana. I am adding grape. So you can add any number of elements to orange. So you can add any number of elements to this array buffer. Dynamically it will increase elements string. Let me use for each loop to process the data. So you can directly use for loop. You cannot directly use fruits. It will print a complete object, but we want to print each element one by one. Then we can go for loop. For fruit. Implies fruits. Then print ln fruit. Yep. So we got all elements too. So in this way we can add any number of elements to array buffer. So dynamically we can add n number of elements to array buffer. There is no limit, Tim. You can add n number of elements. So dynamically it will increase size, Tim. So no need to specify size. So array buffer is a mutable array class. Array buffer is a mutable array class. Okay. Now let's understand tuple, Tim. Tuple is a collection of heterogeneous elements. Collection of heterogeneous elements. First one. Array is a homogeneous elements. Tuple is a collection of heterogeneous elements. Next one, tuple is a ordered sequence of value. Tuple is a ordered sequence of elements. So whatever the order we are storing, same order we can set in. We can store multiple kinds of data into tuple. In our Spark and Scala, we use tuple many times. Example, we are reading a file may be text file may be CSV, file may be Parquet file may be any other format. We read file, we read a row, we convert each row into tuple. A row may contain multiple columns. So we convert tuple into, row into tuple type. Then we apply our processing logic. So tuple we are going to use many times in our Spark and Scala. Okay, let's take a simple example. So first I am creating a tuple type. Val emp1 equal to, I am creating tuple 101 Srinivas and salary is some salary. Okay, and next one, gender I am storing male, and next one I am storing department number. Okay, so salary is a floating point value, employee number is numeric value, and Srinivas is a string, and gender I am taking here just male, single character. So gender is a character. So we have different kind of data type. We have numeric values, we have string values, we have floating point value, we have character value. Yes or no? So tuple we represent using parenthesis. Very, very important point. Tuple we can represent using parenthesis string. So this is one example. So first one, accessing tuple. Accessing tuple. So first one, every tuple uses index. Like arrays, every tuple uses index. Using tuple index, we can access. This is one. And other way, we have a tuple can be accessed. Tuple can be accessed using dot underscore n notation. Dot underscore n notation. So very important point. Dot underscore n notation, where n is a index. Where n is a index string. Index starts from 1. Tuple index starts from 1. Tuple index starts from 1. Array index starts from 0. Tuple index starts from 1. So now I am printing tuple value. Let's say first one, I want to print employee number. So println emp1 dot underscore 1 employee number, emp1 dot underscore 2 ename, emp1 dot underscore 3, emp underscore 1 dot 4, emp underscore dot emp1 dot underscore 5. So in this way we can access string. In this way we can access by using dot underscore notation. First one, underscore notation. Next example, let me try using for each loop. For each loop, for e implies emp1, e implies emp1, bracket start. Let's print println e. Let's close bracket. Let's observe. So here we are getting value e or emp is not iterable. So tuple is not iterable. That's why we cannot iterate it. So we have to use dot underscore notation. First one, we have to use dot underscore notation to access the element. Okay. So this is success. So we got an error saying value for each is not member of this one. Okay. So second example is not possible. Second approach is not possible. Next, let's take one more important example. Tuple within a tuple. Tuple within a tuple or nested tuple. Nested tuple. Nested tuple. Tuple within a tuple. Tuple within a tuple. Tuple within a tuple is called nested tuple. Nested tuple. Sometimes we may get a record. A column contain multiple values. So we want to convert that column values into nested tuple. So in that case, we go for we want to convert value inside a value. In that case, we go for tuple thing. Tuple within a tuple is called nested tuple. Let me take one simple example. I'm taking val my tuple, well, my underscore tuple equal to, so I'm taking a value 1 comma 2 comma, and another tuple I'm taking 3 comma 4 comma, next one let's say 5 comma, next one I am taking 6 comma 7. So this is my tuple. So I created a tuple. Inside this tuple value, third index value and fifth index values are inner tuples. So when I say println my underscore tuple, we are getting entire object, but we don't want entire object. So then we have to use dot underscore notation. Let me println, let's see, my underscore tuple dot underscore 1. Okay, we are getting first value 1. Next I want to second value, I am getting 2. Next I want to read third is a tuple. Inside in a tuple again we have 2 elements. How can we access inner tuple values individually? How can we access inner tuple values independently, individually? So how can we use? So we use dot underscore n dot underscore m dot underscore m notation. So first dot is main one, second dot is inner. So I want to access same thing above, dot underscore 1, I'm going to get 3. Dot underscore 2, I'm going to get the second value. So in this way we use inner tuple values. In this way we can get inner tuple values. So first one, inner tuple means tuple inside another tuple is called inner tuple. Okay, so that's it for tuple setting. That's it for tuple. List thing. Now let's start list. List is a collection of elements team. First one, list is a collection of elements. List is a collection of elements of similar type. Then we can compare array. Array is a collection of elements of similar type, but advantage compared to array and list is dynamic in size. List is dynamic in size. It increases size dynamically. It is a child class of linear sequence trait. Linear sequence trait. It is a child class of linear sequence trait. Traits are similar to interfaces interfaces in Java. We are going to discuss in-depth traits. Okay. So main advantage is it represents the linked list formatting. It represents in linked list form. Linked list form. Okay. So it maintains order of elements. It maintains order of elements. Order of elements. Whatever the insertion order you are inserting, same order it will maintain. Same order it will maintain. And one more important point about list is it allows duplicates. It allows duplicates. We can represent list. We can represent or we can create a list using list constructor. Let's practically see how can we create a list. So I'm creating val li equal to list constructor and pass list of values 10 comma 20 comma 30 comma 40 comma 50 list of values. Okay, then println li, we are printing complete list object. We are printing complete list object, but we want to navigate a list. My requirement is navigating a list. For navigating a list, we recommend for loop to iterate list, to iterate list thing. Here I'm using for I implies li, for I implies li, then println I close for. We are getting values. To iterate list, we use for each. We can use other also. It is highly recommended thing. For each is recommended for iterating arrays, iterating list, iterating set, iterating map, etc. It is highly recommended. So first one, accessing list. For accessing list, first one, A, we can use index setting. We can use index. Let's say print. We can use print li of 0. Index starts from 0. Li of 1. Li of 2. Li of 3. And li of 4. When we try to out of index, we get error. Out of index error. Okay. So index 0. First important one, using index thing. Using index. Index starts from 0. List index starts from 0. Okay. And second approach team. Second approach, we can use for each. We can use for each. It is recommended. It is recommended. It is recommended. For each is recommended. We can create empty list also too. We can create empty list. We can create empty list also. Example, val li equal to list object. We can create empty list, print li. It will print empty object because we do not have any elements. What is the purpose of creating empty list? May we can add element later. We are creating list now. We are creating list now. May we add elements later. In that case, we are going to create empty list. Okay, team. So I want to append elements. Appending elements into list. We created empty list. We want to add elements to list team. So what I'm doing, I'm trying to add element. So li plus equal to let's say I'm adding 10. Plus is not member of li. So what I'm doing, li equal to li colon plus 10. So I'm adding element. So here we are getting error saying reassignment to val. Okay. So instead of val, let me create a li of var type. Let me create a var type. Now let's try to execute this one. Here we are getting error saying type mismatch. Found integer value required nothing. Because let me change the syntax here. I want to store only integer values in this list. I want to store only integer values. That's why I'm trying to append integer value, but we got an error. We got an error saying muted li. Muted li. Let me copy this one and let's understand. Let's understand it. So requirement is appending elements into list. Appending elements into list. This is our requirement. So when we try to append element into list, we are getting error. So now let's understand it. Important to note. By default, list is muted. So we have collection dot muted, collection dot immuted. Array is immutable, but list is mutable. So you can add n number of elements to 20, 30. Now let's print ln li. So 3 elements it is printing. Yes or no? T. And next, very important, very important to note today, very important to note. List allows heterogeneous elements. List allows heterogeneous elements, but it is never recommended. It is never recommended to store heterogeneous. You can store heterogeneous, but list is recommended. Recommended means not mandatory. Scala people recommending take list for homogeneous, not for heterogeneous. List allows heterogeneous, but never recommended. Okay. Next, very important points. Basic operations on list. Basic operations on list team. What are different basic operations we can apply on list? First one, let's take a list of 5 elements. So I'm taking list of 5 elements. Okay. First, I want to execute one function called li dot head function. It will give first element. Li dot tail function. I'm saying function, but I did not use parenthesis. If function not takes any arguments, specifying parenthesis is optional in Scala. I'm using tail. It is giving, other than first element, it is giving remaining all elements. And I want to test whether my list is empty or not. Is empty function. If is empty function returns true, then list is empty. Otherwise, list is contain elements. Sometimes in a loop, we will test whether list is empty or not. If it is not empty, then only proceed to navigate. Otherwise, stop. Okay, so these are some important functions. Important functions. There are plenty of functions. These are some important basic operations. And next one, nested list. Nested list type. List inside list is called nested list. List inside list is called nested list. List inside list is called nested list. Nested list. Sometimes we can store the data inside a list, inside another list. Okay, let me take some examples. Let me take an example. Val n list equal to I am taking list. Under list again I am taking first one, list of 1, 2, 3, list of 4, 5, 6, list of 7, 8, 9. So 3 lists we are using. Inside a list again we have list objects. When I print ln, when I say n list, we are getting complete object. When I use index, print ln, n list of n list of 0, first list object we are going to get. But my requirement is I want to navigate each element list by list. When I say for li implies n list. When I say this approach, when I print li, we are getting list by list thing. Println. Let me use println. I am getting list by, but inner list also I want to process. For that one thing, we can use nested for loop. For L implies li bracket start, then print L. Then close inner for loop. Out of this inner for loop, out of this inner for loop thing, here, oh, sorry. Here I want to print ln inside this one. I'm printing star. So first list we printed, second list we printed, third list we printed. First let me take inner list thing. List inside a list is called nested list. This is one example. Okay. So did you understand him? Nested list? So we discussed some important operations, right? Some basic operations. Along with the basic operations, let's understand some more important operations too. Some more important operations. We have some more important operations. We have size function thing. Li dot size function. It will return size of list. We have 5 elements. I want to max. So we have max function. In a list, I want to find the max value. In a list, I want to find the min value. List, I want to sum operation. And list, we want to product. Product means multiplication. Okay. And we have sorted also. We have a sorted. Already list of elements are sorted. So if your list is not sorted, we can use predefined called sorted. Okay. So we have these many important functions. Along with this one, plenty of other functions also available. Okay, these are important functionalities. That's it for list tip. Yep. In previous session, as part of a collection or complex data types, we understand what are arrays and what are tuple, what are list. Now let's understand set type. So first important point, set is a collection. Set is a collection of elements. Set is a collection of elements of same type. Set is a collection of elements of same type. Array is a collection of same type. List is a collection of same type. Set is also a collection of elements of same type. Okay. Then difference between list and set. First important point compared to set and list. Set does not allow duplicate string. Does not allow duplicates. List allows duplicate string, but set does not allow duplicates. It allows only unique values. It allows only unique values. We have two types of sets. We have two types of sets. Two types of sets. They are first one. They are first one mutable set, or first one immutable set. So this is default team. Default is immutable set. Okay. Second one is mutable set team. Mutable set. So mutable set is not default. We have to import Scala dot collection dot mutable dot set. We have to import this class. If you want to create a mutable set, we have to import this package. Okay. So set provides two types. One is immutable, other one is mutable set. Let's first create a set object, then try to enter values. Okay. So first example team. First example 1. I am creating set object team. I am creating set object. Let's say val s equal to set object I am creating. So when I create a set object, it is creating Scala dot collection dot immutable. I said by default is immutable set, and this is a empty set thing. This is empty set. So we did not add any elements in this set. First important point, empty set. First we created empty set. So whenever we create an object to set class, it will create a set object without any data. Second example team, I want to create a set with some data. Let's say val s equal to a set of elements. I am creating 1, 2, 3, 4. So I created a set, Scala.collection.immutable.set. So we created a set with some values. Yes or no? We created set with some values. Let me create one more set object, S2, values 2 equal to. I'm creating elements 1, 2, 3, 4, again 1, 3, 4. If you observe, first set we do not have any duplicates. Second set I have a 1, 3, 4. These are duplicates. If you observe output set, again we have only unique values. So first important point, I said set does not allow duplicates. If we try to enter duplicate element string, what will happen? It will remove old value, it will replace new value. Okay, so old values are removed and new values are placed. Okay, so first one, set does not allow duplicates. Set does not allow duplicates. It will override duplicate value string with new values. This is one example. Another example thing. Another example. Let's see example 3. I'm creating a set team. I'm creating a set. Val s equal to set of 1, 2, 3, 4, 5. Observe. See the order. 5, 1, 2, 3, 4. Let me create one more set. 6, 7, 8. 5, 1, 6, 2, 7, 3, 8, 4. Let me write this point in this example. Set does not maintain insertion order. List maintains insertion order. Set does not maintain insertion order. Are you observing, team? Are you observing? So then what is the order it is inserting? See, 5, 1, 6, 2, 7, 3, 8, 4. How it is inserting? How it is inserting? It is following hashing mechanism. It is following hashing mechanism to insert elements, to insert data into set team. Insert, it uses hashing mechanism to insert data. It means it takes address of each element and calculates which location it comes. It comes before one, after one. So hashing mechanism thing. So based on hashing, it will insert data. That's why we cannot expect exact order like list arrays. Arrays, whatever the order you inserted, you can access the data type. You can access the data. So this is complete. Up to now we are discussing immutable list. Immutable set. Now let's understand mutable set. Mutable set. Yep. Now let's start mutable set. So immutable set means once we add elements to set, we cannot add new elements to it. set is fixed. We cannot add. But mutable set, you can increase any number of elements dynamically. So let me create a set. So I'm creating set. So here I'm creating a set team. Before that, let me create a mutable set team. First, we have normal set. This is our set. What I'm trying to do, I want to add s plus equal to, I want to add a fifth element. So we are, sorry, it is giving value plus is not a member of Scala dot collection dot immutable dot set. Okay. So what I'm going to do, import Scala dot collection, Scala dot collection dot mutable. Okay, mutable dot set. I'm creating this set object thing. I'm creating this set object. So 1, 2, 3, 4. So let me, instead of import, let's use val s equal to, I'm creating mutable set object. For this one, I'm trying to add it in plus equal to s plus equal to 5, s plus equal to 6, s plus equal to 7. Then print yes, setting 1, 2, 3, 4, 5, 6, 7. Yes or no? So it is mutable team. Mutable means once a set object is created, team, you can add, you can increase, or you can add elements. You can use plus equal to or set contain s dot add function. Let me add a new element. So if element is added successfully, it will return true. If element is added successfully, it will return true team. Let me copy these all examples. We can add elements to set object. We can add elements to set object. So these are different examples too. These are different examples. Now let's understand some important functions. Important functions. Important functions and operations on set. Operations on set. Okay. So first one thing, let's practically see. So first one, I want to find the max value. S dot max. It is the max value, and minimum value I want to find. And I want to find the sum or total. And I want to find the product. I want to find product. And I want to find first element. S dot head. I want to find except first tail, remaining elements. Okay, I want to test whether list set is empty or not. S dot is empty. This function returns true or false. If it returns true means set is empty. If it returns false means set is not empty. So these are some important functions team. These are some important functions of set. We can convert set to list and vice versa. So list to set thing. We have a function, let's say this one, right? Val li equal to s dot to list function thing. No need of this parenthesis. We can use li. Then print ln li dot get class. Li dot get class. So it is saying class Scala dot collection dot immutable dot colon. No. So if you observe here below, we are seeing list object team. List object. It is converted list object. Okay. Have a list team. Val li equal to list of 1 comma 2 comma 3, 1 comma 2 comma 3, 1 comma 2 comma 1 comma 2 comma 3. So we have a duplicates. Print li or print ln li. I'm printing li object to. Okay. I want to convert this one into set object. Val s equal to li dot to set. Whenever you convert list to set, all duplicates are removed, stored as a unique values into set. Print ln of s. Yes or no? So duplicate elements are removed and only unique values are stored into set thing. While converting list object to set, it will remove all duplicate string. Okay, so these are some important examples. These are some important examples of set. That's it for set operation in Scala. Now let's understand. Map is a collection of key value pair. Key comma value pair. Map is a collection of key value pair. Where key should be unique, unique, and value may be unique, may be duplicate, but key should be unique. Yep. Scala provides two types of map setting. Scala provides two types of maps. They are They are first one immutable. So these are by default. By default, every map is immutable. Second one, so if you want to create a mutable map, we have to import Scala dot collection dot mutable dot map. We have to import this class. Okay, all mutable classes presented in Scala dot collection dot mutable. We have to import this package. Okay, so first one, let's create a map object. Example one. Let's create a map object. So I'm creating val m equal to, I'm creating map of key comma value byte string. Every key should be in double quote. Value may be, depends upon the value type. If it is a numeric, we represent directly. If it is a string, we represent in double quote. Okay, so next one b comma 2. Next one c comma 3. Next one d comma 4. Okay, I created 4 objects, and fifth one I am creating duplicate key a. So key is already presented. I am creating duplicate key a, and value is 5. Value is 5. Whenever you try to create a duplicate key, whenever you try to add a duplicate key, what will happen? Observe. Println m. Observe T. Let me copy this code, and after copying, let's analyze. After copying the code, let's analyze. First key is a comma 1. Second key is b comma 2. Third key is c comma 3. Fourth key is d comma 4. Up to this part, there are no duplicate keys. But we are trying to add fifth key. This key is already existed. If key is existed, it will replace value. So a value 1 is replaced with value 5. A value 1 is replaced with value 5t. Okay, so this is one example. Let me take another example, example 2. Let me take another example. So in this example, what I am doing, I am taking state name and its capital. Both are string. Capital is HYD. State name Telangana state. Capital is Hyderabad. State name is Andhra Pradesh. Capital is confusion, but now Amaravati. So next capital is Karnataka, and value is Bang. Next capital is, let's say, next capital is state is Tamil Nadu. TN Tamil Nadu, and value is Chennai. Okay, So I'm taking key value pair string. So this is my key value pair. I created one more object. I want to access set. I want to access map. So first one, accessing map. When I say println, and when I say m of key ts, it will return value. So when you pass a key, it will return value thing ap. So we are getting value. So you can use map reference. You can pass key. This is one. And map contain one predefined function called get. Map dot get, and you can pass. This is another way. And other way, we have map dot get space key. Sorry, map space get. So in this way, map space get space key. So different ways we can access it. But this is at a time we are accessing only one key value. I want access entire values. When I say println map reference, it is printing entire but not one by one. Yes or no? So if you want access one by one, we have to use for each. Thing. So let's see how to write for each. For v implies yes. Let's say instead of v, for key implies m. From map we are getting key. Once we got a key, then you can get the values. So let me println key is okay. So I'm printing plus key plus I'm writing some value, and the value is value is. Then you can call m of key. That's it. Now let's close. So we are okay. let's see thing. So when we use for loop, it gives one pair, right? That pair in Scala we call tuple. So how can we access tuple team? How can we access tuple? Dot underscore notation, dot underscore one. Next one, dot underscore one, dot underscore two, dot underscore two. So in this way we can access. Each key value pair we call one entry. So it returns tuple objects. Okay. So let me copy this example. Let's write out. Let's understand nested map. Nested map. Map inside a map is called nested map thing. Map inside a map. Map inside a map is called nested map. Nested map thing. Map inside a map we call it as nested map. So let's see one simple example to understand nested map. Let me create one map, val emp is equal to, I'm creating a map. In this map, again I'm creating one more map thing. First I'm creating a key. Key is 101 and value is map object. In this map object team, okay, I'm storing tuples. I'm storing tuple team. Let's say this one is emp 1, and in this emp 1 other map I'm storing. In this map I'm storing first key is emp. Yep, instead of this one, let me take map. I'm taking example A. Okay, sample example I'm taking. Map of 1 comma Srinivas, and next I'm taking second employee 2 comma Swati. So this is map of map. Yep, I think one more bracket is missed. Yes, Tim. So I missed one bracket in the beginning. So this is val emp's map of, I am creating tuple. This is inside map. Again, we are creating one more map. That's why we are saying inner map. Okay. Then we can say println, then emp's. It will print entire object. Entire object. So when I say map emps of A, then I am getting inner map. From that inner map, I want to get what? From that inner map, I want to get one by one employee, one employee. So for that one, let's create val inner map equal to. So first we are getting inner map. From that inner map, I want to access employee one name, employee two name. So for that one, we can use inner map of println inner map of 1. Key I am passing. When I pass key, I will get value. Inner map of 2. I am passing second employee key. I am getting data. So we can access data in this way too. So let's copy this example. First example in nested map. Next one team, next important points. I said by default map is immutable. Immutable means we cannot add elements. We cannot add elements to map. But temporarily we can add them. But temporarily we can add elements to map. But once we add, control comes out of, then it will remove. Example, let's say emps plus equal to I am adding key is let's say key is B, okay, and the value let's say we can add in this pattern. Value let's say 100. Yep, sorry, not plus equal to plus T. So we can add element. In this way we can add. But again, when I say println emps, are you seeing newly added key value pair? No. So it is adds only temporarily thing, not permanent. If you want to add new elements in a permanent, then you need to create mutable maps. Let's say mutable maps. So what are mutable maps? So mutable maps, we can add new elements. We can add elements to map. So mutable map presented in presented in Scala.collection.mutable package. Scala.collection.mutable package. So let's take above example. Let me create a map object. So this is map object. Before that map object, I am creating Scala.collection.mutable.map. So for this one thing, I am adding element. So when I try to add element to this mutable, warning, method plus intrite map oops is deprecated. So this approach, it is saying deprecated. So we can use a plus equal to, let's say plus equal to and see some 1000. Let's say Vasu. So plus equal to, not allowing to concat, we can use plus operator. So plus operator is we can use for appending. Okay, then print emps. See, new element. Let's start Scala functions. First, understand what is function. What is function? First one, a function is a group of related statements. A function is a group of related statements. Group of related statements to perform a task. Example, let's take function. Let's take function def, function name withdraw, function name is withdraw, and here it will take parameters stream, and here we start with return type. We specify return type. So let's say return type. We specify colon return type. Then we start a bracket, and inside this one we write a logic. Let's say first, whenever request comes to withdraw function, first step, validate username and password is correct or not. Password is valid or not. Next one, validate account number valid or not. Account number valid or not. Next one, verify withdraw amount less than balance amount or not. Balance amount or not. Next one tip, then perform withdraw operation, otherwise provide proper information to the user. Maybe user invalid, maybe account number is null valid, maybe withdraw amount is greater than actual amount. Whatever the information you want to provide based on the validation, then you can provide. Okay. So if you observe, we return multiple statements inside a withdraw function. All these statements are for performing withdraw operation. That's why I'm saying a function is a group of or set of related statements. Related. Inside this function, we are writing related statements to perform a particular task. Related statements to perform particular task. Okay, next one. In Scala, everything is an object. Everything is a object. In Scala, everything is an object. Function is also called a object. A function is also called a object. Why a function called object? So if you observe here, function is returning, every function returns some value. Every function returns a value. Value may be simple type, right, or complex type or collection type, or any object, or at least it return unit, unit is like void in other languages. Unit is like void in other languages too. Other languages returns void, but here in Scala, if function not returns any value, it will return unit team. Unit means nothing. If function not returns any value, then we will return what? We will return unit. Unit is a predefined class. So when we returned class means it will return class object. Every simple type, it may be int, it may be float, it may be double, it may be long, it may be character, it may be boolean. Every simple type is a predefined class, right? So class means return type is object. Next one, every complex, list, set, tuple, array map. All these are predefined classes. Or we return our class object or predefined class object. Or at least we return unit. So final return type of any function is object. That's why we are saying yeah, function is a object. A function is a object thing. Okay. So why we are calling function is object? This is the reason thing. Okay. Let's understand syntax of Scala function. So first def keyword and function name and parameters list to parameters list and colon return type equal to bracket here. Here we write set of statements, and finally return type, return statement. Okay. One important note here: return statement is optional. Return statement is optional. Last statement become return type. In Scala, automatically, whatever the last statement we are writing, right? That last statement become return type in Scala type. No need to say this is return statement. Automatically Scala identifies last statement as return statement. Okay. Next important point. Parameters are optional. Parameters are optional. Parameters are optional. Next one, every function starts with def keyword. Def means definition. Every function starts def keyword type. So understand, right, team? What is function? What is Scala functions? Now let's start example, team. Let's open command prompt. Let's start a Scala. So first example we are writing example 1. Function without parameters. Here I am defining function def simple parenthesis colon return type is unit bracket start. Inside this one we are writing print ln hello Scala. Just a function close. So function is created successfully. Next, a function call thing. Function call. So we are using simple function. So directly I am calling simple function with a bracket and without a bracket. Without a bracket. Simple without a bracket. See here, warning. It's a warning tip. It's not an error. So warning, auto application to parenthesis. We got an output. In Scala 3, unapplied method like will extra expand into function. So first important point to team, if function not takes any argument, calling function with a parenthesis, without a parenthesis, both are same. Both will work team. Okay, both will work. This is first example. Next one team. Example 2. Example 2. Here I'm taking function with a parameter string. Function with a parameter. Example 2. Function with a parameter. Function with parameters. So I'm defining the function def sum. This sum function b colon int equal to bracket start, and inside this one we are return a plus b bracket close. This is function declaration. I am calling println. I am calling some function. I am passing 10 comma 20. So we got an output. You can directly call sum of 5 comma 10. Okay. So function with the parameter string. We declare function with parameters. So parameters we declare inside parenthesis. These are parameters. At the time of function call, we have to pass functions. Sorry, we have to pass parameters. Okay, team. So at the time of function call, we have to pass functions. Sorry, parameters. Let's understand one line function, team. In a single line, you can define a function. You can provide definition. You can provide definition. Let's say def quick date and name colon string, then equal to, I'm writing yes colon hello, and that dollar name, whoever name we are passing as an argument, we are saying hello XYZ, hello Srinivas, hello C family, hello Swati. Okay, so single line, we are defining function, we are providing definition. We are calling quick greet, then I am writing Srinivas. So I got an output saying hello Srinivas. I am writing one more message saying quick greet C family. println, I'm getting hello C family. Yes, sir. So we can call a function. We can call a function. So here in single line function, function declaration, function definition in a single line. We are calling that function. So calling function is same, but defining in a single line and providing definition in a single line. Functions, one line functions it is. One line functions. Next, very important one, nested functions. Nested functions. Function inside a function. Function inside a function is called nested function. Function inside a function is called nested function. Function inside a function is called nested function. First one, Scala allows this. Java does not allow this feature, but Scala allows this feature. We can call nested function only within the function. We can call nested function only within the function, only within the outer function thing, outer function. Outside of outer function, we cannot call directly. Outside of outer function, we cannot call directly thing. Okay. So let me take one sample example to understand nested function thing. I'm writing def function 1 colon unit equal to bracket start. Inside this function, I'm writing other function function 2 colon unit equal to bracket start. Then inside this one, I'm writing println welcome to inner function or nested function table. So close this inner function. Outside of inner function, inside main function, I am calling function 2. I am calling function 2. Then close outer function. We are calling outer function 1, but it will call inner function internally. Okay. So inner functions, when I say function 2, then it will give left and right. Hey Srinivas, what is this? I cannot understand. Where is function 2? Where is function 2? It is giving that information thing. So inner functions we can call only within the outer function. We cannot call directly thing. We cannot call directly outside of outer function. Okay. Like normal functions, we cannot call inner functions outside of outer function directly. Okay, team. Let me copy these things. Next important one, recursive function team. Recursive functions. Recursive functions. recursive functions. A function calls itself is called recursive function. A function itself is called recursive function. Recursive function thing. A function calls itself is called recursive function. Let's take one example, then understand what is recursive function, how it will execute. Them. So first I am calling I am defining def let's say factor function. So factorial means when I say 4 factorial, team, so we get 4 into 3 into 2 into 1. Okay, so let me write this example. So in fact, we are taking input. Here we passed as a 4. 4 less than or equal to 1? No. Else part we are going 4 into. So it is create a function object. So first we are calling factorial function and we are passing 4 as an input. Then it will call factorial function. Here we are checking 4 less than or equal to 1. Condition false. If it is false, what we are doing in else part we are doing, first we are checking if condition is false. Then inside else part we are writing 4 into. Again we are calling fact function. We are passing 3. We are calling fact function. We are passing 3t. Then on top of this function object, it will create one more function object. Here it is checking 3 less than or equal to 1. If 3 less than or equal to 1, no. It comes again we are saying 3 into fact function we are calling, we are passing 2. On top of this one, again it will create one more function object. In this function object, it is checking 2 less than or equal to 1. If 2 less than or equal to 1, no. Then it comes to else part. Inside else part, we are saying 2 into fact function we are passing and we are saying 1. Then again it will call another function object, fact function object. It is checking 1 less than or equal to 1, condition satisfied. Here what we are saying, return n. Return n means it is returning 1. So this statement is replaced with 1. So 2 into 1. is going to replace here 2. 3 into 2, 6. It replaces with 6 thing. 4 into 6, 24. This function call replaced with 24. So a function calls itself is called recursive function team. Inside function, we are calling same function. That's why we are calling recursive functions. Function calls itself called recursive function team. Let's start. In this session, we are going to discuss anonymous functions. Anonymous function means a function without a name. A function without a name is called anonymous function. A function without a name is called anonymous function. The main advantage of anonymous function is wherever we require functionality, we can write anonymous function, because a function without a name is called anonymous function. There are different types of anonymous functions. So first one, let's understand anonymous function. Let's understand first one, anonymous function with one parameter. Anonymous function with one parameter. So first one, anonymous function with one parameter. So first one, how to define? So I'm writing var variable name equal to anonymous function starts parenthesis, ends with parenthesis. Here we are passing one argument. One argument. So x colon int. Then here what I'm doing, I'm implementation. So I'm incrementing value and I'm returning incremented value. So this is anonymous function without any name. This anonymous function incrementing 1 and returning value. We are storing that returned value to increment variable. Okay. How to invoke? Invoke anonymous function thing. So here var x equal to increment. I'm calling increment variable and passing 10. Then print x, println x. Then I will get output is 11. Let's practically see. Open command prompt, start Scala. So I'm defining var increment equal to x colon int, and we are providing x plus 1 implementation. Then I'm calling, you can call like print instead of declaring variable. I'm calling increment variable. I'm passing 10. I'm getting output is 11. So this is my example thing. This is simple example to demonstrate anonymous functionality. Okay, team. So anonymous function here, this is anonymous function. There is no name associated here. Result we are storing into one variable team. Final result we are going to store in one variable called increment. So you can take any number of variables. There is no limit. Second example I am taking. Second approach, anonymous function with multiple parameters. Anonymous function with multiple parameters too. Anonymous function with multiple parameters. So let's take a simple example to demonstrate anonymous function with multiple parameters. See, I'm taking val result equal to or let's say mul equal to, and I'm taking anonymous function two parameters x comma y, two parameters. Implementation I'm writing x into y. This is my anonymous function. I'm writing function call, so mul variable, and I'm passing 10 comma 5, 10 into 5. We got 50. Yes or no? So we return one anonymous function which is taking two arguments. We can take an anonymous function with any number of arguments. We can take anonymous function with any number of arguments. So there is no limit. You can take one argument, you can take multiple arguments. Third approach I am explaining, anonymous function without any argument. Anonymous function without any arguments. Without a parameter, or without a parameter or argument. Okay. So let's take a simple example to demonstrate anonymous function without any argument. I'm taking val v equal to, variable name is v, just without argument. And what I'm doing, so I'm returning value type. I'm returning value. So here return, you can return any value. Let's say I'm returning 10. You can return any value. So now print v. We are getting function name. Yes or no? So let me declare one more way. Here I'm using curly braces. Okay. Now let's execute the print v. Okay, we are getting function name. Now let's execute in parenthesis. Value I am putting in parenthesis. Okay. I'm calling function. So in three ways, we got output as just a function name. Yes or no? We called variable v. Variable v, it is stored this function name into variable. Yep. So anonymous function without any argument. We are defining anonymous function without any argument. This anonymous function returning value 10. Okay. So if I print variable name, I'm getting only function name. Okay. So if you want to print this value, then we have to call in function approach with this anonymous variable without any argument. Okay. So previous also we passed one argument, right? Multiple arguments. Here we are calling a function without passing any argument. This approach we have to use. Okay. Yeah. So next one, anonymous is completed. Next one, functions with variable, functions with named arguments. Functions with named arguments. A function with named arguments. Let me write one simple example so that we can easily understand what is function with named arguments. Let's say I'm writing a function def function 1. Here it is taking two arguments, a colon int type comma b colon int type. So I'm specifying return type optional. Default return type is unit. Okay. So what I'm doing, I'm printing print ln a is a. I'm printing a. Next one, print ln b is. I'm printing. Next one, close this function. Okay, so I'm calling function 1 println. I'm calling function 1. No need to call println. Directly you can call function 1. Function 1. We can call function 1. Okay. So pass two arguments. When I pass 10 comma 20, I'm getting output is 10 is going to store in a variable, 20 is going to store in b variable. Okay. So next one. So instead of a, you can use plus operator there, comma. We can use plus operator. Let me change here. Instead of comma, let's change plus operator. Now let's call function 1 and pass value. A is 10, B is 20. What is our main requirement? Function with named argument. what are function with named argument? So while calling function 1, we can use variable names a equal to 10, comma b equal to 20. And one more, order also you can change it in. Order also you can change. B equal to 200, A equal to 100. City. So variable order also can change. If it is a named arguments, then you can pass A as a first variable or A as a second variable in a function call. The main advantage of named arguments are you can pass in order. Sometimes, let's say some sales data we are passing, sales data variables we are passing XY function. We do not know any order. We do not know order of variables in a XYZ function. We know variable names. XYZ function taking what variables we know. But only one problem is we do not know order. Then use named arguments, sales ID, sales price, location, agent, etc. Any order thing, any order. So we know the parameter names. We do not know what is the order. Then use named arguments. You can pass any order. So this is one of the important feature in Scala. Okay. So next very important concept in functions. Now let's understand functions with variable arguments team. So before going to discuss function with variable arguments, I'm explaining one scenario. I want to write add function to perform addition for two variables a comma b. I want to write C for three variables a comma b comma c. I want to perform addition for four variables a comma b comma c comma d. I want to write five variables a comma b comma c comma d comma e. We don't know how many variables we require. We don't know how many variables we may require. If I write multiple functions, what will happen? If I write multiple functions, what will happen? It increases the program length, but the logic inside these functions is same. Logic inside these functions is same. Performing two variables or three variables or four variables or five variables or depends upon the number of variables user is passing. So if logic is same, writing multiple functions increasing program length, it will increase program length thing. How could we resolve this one? By using variable arguments. Functions with variable arguments. Here should be at least So this variable number of arguments can accept any number of arguments. It can accept any number of arguments including including zero arguments string. Including zero arguments, we can add any number of arguments. First one, let's take simple example. Yep, let me write before example. Let's write one more point. Variable argument appending with variable argument appending with star operator to indicate variable arguments, variable argument. Let's take one example so that we can clearly understand. Def add, and add it is taking n colon string star equal to bracket start. Okay, so inside this bracket I am writing, let's say control C. So I am taking, it come out from Scala prompt also. Control L. I am writing a function. So def add function. I am taking variable int star. We are going to take integer variable type. Bracket start. Here I am taking var result equal to 0. Okay, next one I am writing for n1 implies n, bracket start. Here I am writing result equal to result plus n1. Close this for. Then finally I am writing message saying print sum is plus result. Close function. I am calling add function. I am passing zero arguments. Output is 0. I am calling some function passing one argument. I am getting output is 10. I am calling some function by passing 2 arguments. I am calling some function by passing 3 arguments. I am calling some function by passing 4 arguments. I am calling some function by passing 5 arguments. Understand, right? So this variable is internally converting array. This variable is internally converting array team. We are not writing anything. It is internally converting array. Okay. So variable number of arguments converting array. So this is very, very, very important feature in functional oriented language team. Instead of writing multiple functions for same operation, we can take a single function by using variable arguments team. Variable arguments. Okay. Now let's understand default parameter values for a function. Sometimes we can declare a function with multiple parameters as a multiple parameters. While calling that function, we have to pass all the values. Otherwise, we will get error. Let me take one example one. Understand the scenario. So I am taking a function team, def function2. It is taking two variables team. It is taking two variables. It is taking two variables. So here what we are doing, we are printing A, we are printing B. We are printing B. Okay. So function2. When I call function2 without passing any arguments, it will give left and right. When I call function2, I am passing only one argument. It is giving left and right. When I call function, if I pass two arguments, it is working. When I call this function with three arguments, my requirement is only two arguments. So if you forgot to pass values to this function, we are getting issue. So to resolve this problem, either we can declare variable arguments function or default argument string. So how could we resolve this function? So here, let's say default value I am passing a equal to I am passing 5, b equal to I am passing 5. So this is my function 1, function 2. I am calling function 2 without passing any argument. I am getting 5, 5. I am calling function 2 with passing one argument. It is successfully working. First argument is going to store in A. I am calling function 2. I am passing two arguments. All the situations are working successfully. Clear team? So when we go for this kind of arguments, sometimes programmatically, we may forget to pass values to function. If function taking values, we may forget to pass the values. If we forget to pass the values, it will not execute. It will give error because function is taking arguments. You are not passing required arguments. You are not passing single argument sometimes. You are passing only one argument. Number of arguments are more than one. Then your your function calling is failed. So to resolve that problem, at the time of function definition, we can provide a default values to variables. If user not pass any value, Scala takes default values. If user pass any value, it will consider user provided values instead of default values. Stream. Okay. Yep. Now let's understand higher order functions. Higher order functions means a function takes another function as a function takes another function as a input. Another function as an input. Input function would execute first. Input function would execute first. So these input functions we are calling higher order functions. Let's take example. Let's take example team. So higher order functions means another function as an input function. So input function would execute first. Example, we have two functions setting. These are two different functions. These are two input functions. Example, we have two functions. One is even numbers function. Even numbers function. In this even numbers function, we are taking list of values. We are finding even number or not. Then we are creating even list. Finally, we are returning even list. So what I am doing, I am calling this even numbers function by passing list of values. It is written even numbers. First example I created and I tested. Second one, I created odd numbers function. It is taking list of values. It is finding odd numbers from that list of values and returning odd number. If a number is not divisible by 2, then we can say odd number. If a number is divisible by 2, we are saying even number. Then I am testing odd numbers list by passing this one. I got odd numbers. First one, I created two functions setting. Okay. So now I'm writing higher order function. Higher order function. In this higher order function, observe what I am writing. Higher order function implementation. So I am defining one function. I am defining one function. Function name is filter data. This function takes another function as an input. First argument is another function as an input, and second argument is list of values. List of values. First argument is another function. Second argument, list of values. These list of values we are passing to another function. Any function. You may take even numbers, odd numbers, XYZ function. For that function, we are passing whatever list of values we are getting. Then that function returns values, right? We are storing in variable. We are printing that values. Okay. So let's see function call. Filter data function call. Filter data function call. So we are calling filter data function. We are passing function name is even numbers and list of values. So it comes to filter data. Function name is even numbers. So this function C variable is replaced with even numbers. So for even numbers, it is passing this list of values. List of values. Then this statement will call even numbers function, executes this function. This function is returning result. We are storing result and we are iterating result. We are printing that values. Second, same filter data we are calling. This time we are calling odd numbers function. So here we are calling odd numbers function. Odd number function returning that odd values we are storing here. We are printing odd values. Okay. So this is called higher order function. This higher order function will execute first. Okay, that's why we are calling higher order functions. In higher order function, a function takes another function as an argument. That input function should execute first. Okay. Let's start. In this session, we are going to start object-oriented concepts in Scala. So what are different object-oriented concepts available? And we will discuss what is class, what is object, what is constructor, what is trait, what is polymorphism, what is inheritance, and how can we implement in Scala language. Okay, I said Scala is both procedure oriented and object oriented programming language. Object oriented programming language, yes or no? It's both procedure oriented and object oriented programming language. In object oriented language, we have object oriented concepts mainly. So we have class, and next one object, and next one polymorphism. So before that, first important one is encapsulation. So to implement encapsulation, we use class and object concept. To implement encapsulation, we use class and object concepts. And next one polymorphism. And next one inheritance. And these are main three important concepts of encapsulation, object oriented features. And very important one, abstraction, etc. These are very important object oriented concepts. So first let's understand what is class. What is class? What is class? Yes, what is class? Spark and Scala is our class, right? Tell me, Tim, what is class? So first one, class is a user defined data type. Class is a user defined data type. So example, let's say class student. Inside this class student, we will write variables and functions. So instead of storing single value using variables, we have collections. We can store multiple values. Yes or no? So if you use arrays, we can store same type of data. If you use list set is recommended for same type of data. Compared to list and arrays, list is a dynamic in size. And another important collection is map, key value pair. But advantage of class is you can create different kind of data inside a class. So instead of same type of data team, we can create different kind of data. A student contain numeric data, a student contain string data, a student contain boolean data, a student contain floating point data. Yes or no? So class is a user defined data type. And next one, class is a blueprint for creation of object. Class is a blueprint for creation of object. The main what is the meaning of blueprint for creation of object? So for class, memory is not presented in runtime. Class is just a logical name. It's a logical name. Memory allocated only for object. Memory allocated only for object. So how much memory we want to reserve in a RAM? How much memory we want to reserve in a RAM for class? So inside a class, how many variables we declare, that much memory internally allocates in a RAM. That's why we are saying class is a blueprint for creation of object type. And next definition, one more important definition, class is a collection of objects. Collection of objects. You can create n number of objects to class. Student class, you can create n number of objects. Example, Srinivas is one object. Swati is one object. Alia is one object. Meena is one object. Badri is one object. XYZ is one object. So for student class, we can create n number of objects. There is no limitation. Okay. Next one, every class contain, every class has, first one thing, data members. Data members means variables. And next one, methods are functions. And next one, very important one, constructor. Special member functions. Constructors are nothing but special member functions. And additionally, very important one, it may contain blocks. Every block starts from flower bracket or curly braces, end with curly braces too. So a class contain data members, a class contain method or functions, a class contain constructors, a class may contain blocks. And a class also contain team. A class also contain nested classes. Class inside a class. And next, very important thing, superclass information. Superclass information, nothing but parent class information. In superclass means parent class too. Parent class information. So every Scala class has, Scala class has these properties too. Okay, let's take simple example. So I'm creating one simple example here. Let me open IntelliJ IDE. Let me click on IntelliJ IDE. So for developing Spark and Scala object-oriented programming language, we can use interactive cell. We can use IDE. So interactive cell may little difficult because bracket starting, closing. So little difficult. I'm not saying we cannot write. We can write in object-oriented programming also, but instead IDEs are recommended. IDEs are recommended. Yep. First example I am taking, example 1. So in this step 1 IDE I am using, here I am using IntelliJ. So first start IDE, I have already started. Second step 2, create a project. I have already created a project. Second one, create a project. Step 3, create a package. So we have already created a package. Here let's expand. Main Scala. Here we have, inside this one, I am creating a package. Right click on Scala, go to new, go to here package, write com.cfamily.learning. com.cfamily.learning. So first one, I am creating package. So package name I created com.cfamily.learning. So I created a package. What is package? We are going to discuss it. Okay. So I created a package. In that package, next step, step 4, create a class. Very, very important point here. We can create classes like, so right click on this package, new Scala class. Here we are saying class, case class, object class. We can create class, object class, next case class, and trait. We can create different kinds of classes. First one class, next one object, next one case class, next one trait. So class, case class, object class, trait. Case object, right now let's ignore case class and case class team. So we can create a class, case class, object class, and trait. These are 4 important classes. Mainly in Scala, mainly 2 types of classes. Two types of classes. They are first one client class, and second one service class. Client class and service class. Client class, we create client classes. We can create we can create using object class. Object class, it should have main function. Okay, service class can be created using class keyword. Service class can be created using class keyword. Here we can write our own functions. To perform business logic thing. So here we will write our own functions to perform business logic, like withdraw, deposit function, balance and query function, etc. Depends upon the business purpose, we will write different functions. Okay. So in first example, I am creating client class team. So right click, select object, and here I am writing class name is test or demo. Click on OK. So class is created. In this class I am writing def main, and inside this one I am writing println welcome to Scala object oriented programming. Okay, let me take this one. So first what I am saying, create a class. Here which class we are creating? Object class. Program name we given demo.scala. Next one, step 5, run Scala program. Okay, so first one, let's run Scala program. Right click on this one, run demo. So we got output is welcome to Scala object oriented programming. So we return, first example we return client class called demo class. Now I am writing service class. So in this next example I am writing example 2. In class example 2 I am writing a Scala program may contain any number of classes. So here what I am doing, I am writing one class called class employee started. Inside this one I am writing where empno int, where emp int equal to 0, and next one where name equal to string equal to, just initially I am assigning null. Okay, so this is my class team. this is my class. What I'm doing inside this demo main class. So here, um, here I'm just creating object. I will explain what is object after this example. I'm creating object val e equal to new employee. I'm creating an object. Then println e dot empno. Next one, println e dot ename. Name. Okay, I'm just printing. Right click on this program. Let's run demo. So now we are going to get a different output, 0, null. Previous example is different one. So in this example, we are going to get an output is 0, 0 and null. First one 0 and next one null. So this is first two examples for what is class string. How can we create a class in Scala using IDE? So we created two types of classes. One is client class, another one is service class. So client class should have main method. Service class can be created using class, and here we can write service functions. In our example, we did not write any service functions. We just created a variables. Later we are going to see it. Just I created a program. Okay. Now let's understand what is an object. We understand what is class, right? Now let's understand what is an object. Class is just logical name. Class is a logical name. It does not have any memory, physical memory. So you may have a doubt like you are saying there is no physical memory, then where it is created? Once we save this program, once we save this demo.class, it will save in a hard disk, right? It means it has a memory, right? So you may think for class memory is allocated in hard disk space. It's wrong thing. So when we say memory is allocated for class, whenever anything created in a RAM, then only we can say memory is allocated. Okay, not hard disk space thing. So for class is just a logical name. It does not have a physical memory. So object is nothing but memory for class. So team, don't confuse with the object class and object. Object class is different. It's a client class. So if you observe, it is capital O. Okay, capital OT. So terminology object means it's a memory allocated for class. How to create an object? How to create an object to class. So to create object to class, we use new operator team. We use new keyword. So example, this is one simple example. To create an object to employee class. Okay. So we can create n number of objects too. We can create n number of objects. N number of objects. We can create n number of objects to a class. Example. So you can create n number of objects. Let's say first I created E1 object. Next I am creating E2. Next I am creating E3, E4, and so on. En. Let's say E2, E3, E4, and so on. En. You can create n number of objects to a class. Again, I am coming back to, I said class is just a logical name. It does not have a physical memory. For this one, generic example I am giving. Question, have you seen tree? Question is, have you seen tree? Okay. Can anyone tell me, have you seen tree? Okay. So one of our friend is saying, yes sir, I see a mango tree, I see banana tree, I see coconut tree, I see grape tree, I see orange tree, I see lemon trees. My question is, have you seen tree? I did not ask mango tree, lemon tree, banana tree, orange tree, grape tree. I asked, have you seen tree? Did I ask, have you seen mango tree, banana tree, orange tree? No, right? So tree is a logical name. Logical name. Is there any physical existent? No. Mango tree, banana tree, orange tree, etc. These are objects of tree. Yes or no? Objects of tree. So this is just a logical name. Means a tree has a root and it has a different leaves, and it has some trees has a fruits, right? So tree has different properties. So based on that properties, mango tree is created, banana tree is created, orange tree is created, etc. Yes or no? So these are objects. Okay. So objects has a memory. We can touch and feel. So when I say we can touch and feel, don't try to create a class employee and open your laptop and open RAM and don't touch thing. It will give shock. Touch and feel means, so physical objects we can touch and feel. Physical objects we can touch and feel, but our software objects we can see memory allocated in a RAM. Okay. Okay, Nati. Clear? So we can create n number of objects. There is no limit. You can create n number of objects. So first definition, we understand what is class and what is an object. Now let's we understand how to create a variables inside a class. So a class may have data members, methods or functions, constructors and blocks, nested classes and superclass information. Okay, so we understand how to create a data members. Now let's understand how to create a functions. Now let's understand how to create functions in class. We already know what is function, how to develop function, yes or no? So what I am doing inside this employee class, I am using def set employee, okay. So it is taking variables like empno colon int comma or envo comma int, next ename colon string. I am creating one function. Inside this function I declared two variables. Then empno equal to envo, I am assigning envo. Name equal to, I am assigning ename. Next I am writing one more function. So next one, def get employee, def get employee. So this get employee function not taking any parameters. Okay. So here what I am doing, I am writing logic return. So empno plus I am writing some message plus name. So I am returning employee number and employee name team. Next one, inside this program team, here first one I am setting e dot set employee. For this one I am passing first one 101 and Srinivas. I am passing two parameters to. Similar way, I am creating one more object. So this is E1 dot set employee. Next I am creating two E2 and E2 dot set employee. Here employee name is 102. Employee number is 102. Employee name is Swati. Now what I am doing, I am calling println E1 dot get employee. Next one println E2 dot get employee. So we are writing two functions, business functions or service functions. One service function is setting employee details. One service function is returning employee details. So by using object reference variable, we are calling business functions. Okay. So let's right click on this program, run demo. So here E1 dot get employee, E2 dot get employee returning empty values. Let's say, let me remove these parentheses. Now let's execute, right click on this program, run demo. So we are getting, so a function, if function not takes any arguments, then we can use function call without parentheses. We have already learned in a functional oriented. So we are calling these variables, but we are getting empty data. We are not getting 101, we are not getting 102. Yes or no? Why we are not getting data, even though we assigned values to employee number and employee name? Team, if you observe, get employee previously, say team unit. We did not change return type. That's why I changed the return type unit to string. Now it is working team. So return type should be the value what we are returning. Okay. So for our get employee function, by default it is created unit. So you have to check return type also. What type of data we are returning? Even though if you write a return keyword, it should not return value. When you not specify return type in a function, default return type is unit. Remember team, we have already discussed these things in functional oriented programming. Means we know how to return data. Yes or no? So output is these values. So this is our output. Yes or no? Now let's continue. We understand what is class and we understand what is an object. Now let's understand what is instance. So first one, instance is nothing but it is a memory. It is a memory allocated for class. Simply we can say instance is nothing but a object of class. Instance is nothing but object of class. Object of class. We have already object concept. Then again, why instance came into picture? In computer terminology team, when we say, whenever we click on this, any of this software, let's say I'm clicking on Firefox. We can say Firefox instance is created. When we click on VLC media player, we can say VLC media player instance is created. When I click on PyCharm, we can say PyCharm instance is created. When I click on Oracle VM VirtualBox, we can say Oracle VM VirtualBox instance is created. So in computer, if anything memory allocated in a RAM, we can say instance T. Instance. If anything memory allocated, we can say instance is created. Instance nothing but memory. If that memory is allocated for class, then we are saying object T. Object and instance is same. Memory allocated for class means we are in object oriented terminology, we are calling object. Okay. Object is nothing but a instance, nothing but a memory allocated in a RAM. Okay. Clear, right? So instance nothing but it's a memory allocated in a RAM. If that memory is allocated for class, we are calling object team. Yep. Let's understand what is constructor. First important point, a constructor is a special member function. It's a special member function. Like how we created functions, constructor is also a special member function. What is the difference between member function and constructor? A constructor automatically executed when when object of when object is created for class. When object is created, it is constructor automatically executes, but function we have to call. But functions we have to call manually. Functions we have to call, but constructor automatically executes when we create an object. There are two types of constructors in Scala team. There are two types of constructors in Scala. They are important. First, very important one, primary constructor. And second one, auxiliary or secondary constructor. Auxiliary constructor or secondary constructor. First one is primary constructor and second one is auxiliary or secondary constructor. Okay. Now let's understand primary constructor. So understand first important point about primary constructor is it declared as part of class name, unlike Java inside a class we declare constructor, but along with the class name we will specify constructor, or we will define, or we will declare primary constructor team. Let's see one practical example. Example 1. I'm writing class student. I'm writing class student class close, and set of statements. And in this example, where is constructor? In this example, we did not declare any constructor. Yes or no? So if you not declare any constructor, Scala adds default constructor. Very important to note. Very important to note it. If we did not declare any constructor, Scala compiler adds default constructor, default constructor team, default constructor. So first one, it will declare default constructor. First important to note. This is first important to note. Okay? And next important to note is very, very important to note. Default constructor will not take any arguments, will not take any arguments. Default constructor will not take any arguments. Let's observe object creation. So how we create object? Val s1 equal to new student. Yes or no? New student. So this is object creation. If you observe here, this one, parenthesis. This parenthesis represents, it will call no argument constructor or default constructor type. It will call no argument constructor or default constructor. So we did not define any constructor. Compiler added default constructor. This statement will call default constructor. Okay. Let's take another example about this primary constructor. Example 2. In this example, I am writing one default constructor, primary constructor type. So what I am doing, I am writing constructor as part of a class declaration. As part of class declaration, I am declaring primary constructor. So it is taking 2 arguments. So primary constructor. Okay. So while creating object to this class, while creating object to student class, we have to pass arguments. Otherwise object will not create. So if you use this syntax for creating an object, it will not valid. It is not valid because we are creating an object. So it is not valid. So which is valid statement? So here we have to pass 2 arguments. It is valid. Okay. Clear, right? First statement is invalid, second statement is valid because our class is taking 2 arguments. So if any constructor define inside a class or as part of class, while creating object to that class, we have to pass arguments thing. Let's take one complete example to implement this primary constructor implementation thing. Let's see it. First, I am writing one class student, and this student is taking 2 arguments, id : int, sname colon string, sname colon string. And in this, I am writing some statements saying, let's say def show function. In this show function, what I'm doing, I'm writing logic to print. I'm writing logic to print student data. Let's say println ID and name of that student. Yes name. I'm printing ID and S name. Okay. So inside this test class, this is service class. Service class. Service class. And this one is client class. Client class. Inside client class should contain main function. First important one. In Scala, client class should contain main function. Inside client class, we create an object to service class. Well, S1 equal to new student, and I'm passing 101 and student name, the great student. And I'm calling S1 dot show. That's it. So we are creating a class with the primary constructor. That primary constructor is taking 2 arguments. And inside that class, we are creating one function. And inside client class, we are creating object to student class. Then we are passing arguments. Then we are calling function of student class. Okay. Now right click on this program, run test. So we got 101 Srinivas. Yes or no? So while creating an object, we passed arguments. Then those arguments are assigned inside a class variables. Okay. So this is our example. So primary constructor we discussed one example. Now let's understand secondary constructor. Now let's understand secondary constructor or auxiliary constructor. So first important point about secondary constructor. Secondary constructor we can take inside a class. Primary constructor we take as part of class declaration. As part of class declaration, we will take primary constructor. Secondary constructor takes inside a class. Okay. And next very important point, secondary constructor declared or defined using this keyword thing. This keyword in Scala. So by using this keyword, we can declare secondary constructor. In Java, constructor name is class name. So that is Java rule. In Python underscore init underscore is a constructor name, but in Scala, we declare constructor using this keyword. Okay. So next very important point, your class may have primary constructor, and secondary constructor. Okay. First important point, your class may have primary constructor and secondary constructor. Okay. So Scala first executes primary constructor. Scala first execute primary constructor. Very important point. First it will execute primary constructor. Then it will call secondary constructor. Okay. So my requirement is I want to call secondary constructor. I wanted to call secondary constructor. This is our requirement. Instead of primary constructor, I wanted to call secondary constructor. Then first we need to call primary constructor inside secondary constructor. Inside primary constructor, we have to call primary constructor. So inside secondary constructor, we have to call primary constructor. Now let's see one sample example for demonstration purpose. Let's say team, primary constructor we are taking 2 arguments, and inside a class I have another argument. Let's say I'm taking employee class, employee ID, employee name. Okay. And inside a class I'm taking val sal colon int equal to 0. Okay. So show here we are displaying employee ID, employee name, and salary of employee. So this is our show functionality. Okay. So total we have 3 variables. 2 variables are assigned by using primary constructor. Third variable by default we are assigning default value. Instead of default value, we are going to write one constructor, secondary constructor def this function, and we are taking s colon int bracket start. Okay. S colon int bracket start. So first one, def this function thing. So here we are writing message println inside secondary constructor. I am writing message inside secondary constructor. Still we are seeing red mark. Let's place cursor here and see this expected. This expected. Already we written this. Again it is giving error saying this expected. Means inside secondary constructor we have to call primary constructor by passing arguments. Okay, so let's say here we are taking id colon into comma ename colon string comma and salary. So inside this we are passing id comma ename. Okay, so we are passing two arguments. Now if you observe, that red mark is removed. So what I said here, remember, I want to call secondary constructor directly. Inside secondary constructor, first we need to call primary constructor. Otherwise, your program will not compile. We got red mark. Did you observe it? We got red mark. It is not compiled. Okay. So inside secondary constructor, first statement would be the calling of primary constructor. Okay. Now inside this one, let's create a employee object and let's create employee name, employee ID, employee name, salary of employee. Okay. So now it is working successfully. Let's execute this program. So we got an error saying depreciations in total, run with the deprecations. Okay, so first one, employee is already defined as class employee. Okay, what I'm going to do, let me remove this demo, because inside a demo class we declared employee. Now let's save this program, right click on this program, run test. So now we got output is 101 Srinivas. Salary we are getting 0 because we did not assign here. Chal equal to yes, right? We have to assign. We are getting error. So use this dot chal. Still we are getting error. So val, okay. So first of all, this is val type. Let's change it to var. Now it is working successfully. Now right click on this program, run test. So this time we are going to see salary which we assigned. Okay, let's copy this program. So as part of secondary constructor, we discussed what we understand. We can declare any number of constructors inside a class. We call it as secondary constructor. Secondary constructors we declare by using this keyword. Inside secondary constructor, first statement would be the calling of primary constructor. Okay, so these are very important points we have to follow. So next we continue singleton classes. Now let's understand singleton class in Scala. The first important point, singleton means we can create only one object. We can create only one object. We can create only one object to class. So whenever you create any singleton class, Scala allows only one object creation. It will not allow multiple objects. How can we create singleton classes in Scala? So next important point, how can we create singleton classes in Scala? So for that one team, if you create any class, using object keyword instead of class keyword, if we create any class by using object keyword, then that class is called as singleton class. That class is called as singleton class team. If any class is created using object keyword, we call that class as singleton class. Very important point I am writing. For singleton classes, we cannot create object using new keyword. Who will create object to this singleton classes? Scala will create. Inside singleton class, we may have different functions. How can we call? Without creating an object, how can we call singleton class variables, singleton class functions? I said for singleton, we cannot create an object using new keyword. Okay, no problem. I said one more important point. For singleton, we can create only one object. But problem is by using new, we cannot create. So who will create this singleton class object? Scala will create. Okay, object is created. A class may contain variables. A class may contain functions. How can we call variables? How can we call functions of that singleton class? How can we call singleton class variables, and functions? How can we call singleton class variables and functions? First one, important point, by using singleton class name. Super. Scala provided a feature, class name dot variable name, class name dot function name, class name dot variable name, class name dot function name. Let's take one simple example to demonstrate this singleton class functionality. Okay, let me write one class. Let me remove this EMP class. So I'm writing singleton class, singleton class. So class, no, first one, by using object keyword, we can create singleton. Object, single, bracket start, bracket close. Inside this singleton, I am writing a function def hello, and I am writing println. I am singleton class. I am singleton class. Super. Inside function we return I am singleton. Oh, you are singleton now. Then I am trying to create an object. So what I am doing? I am trying to create an object. Val s equal to new single. New single. It is giving error. It is giving error. Okay. Let's say, let me create a single is predefined function is there. Now let's trying to create a singleton. Class name is singleton. Srinivas, you said for singleton class object, singleton, for singleton, we can create an object. We cannot create an object using new operator, but it is allowing. Okay, let's take this example and let's see print or sorry, let's say s dot get sorry s dot hello. Here it is giving an error. When I say s dot hello, we are getting error. So this is first approach. Let me comment this one. So let's write, sorry, let's write singleton dot hello. It is working. Second approach is working. Right click on this program, run, test. So we got an output. Yes or no? Let me copy this one. Okay, team. So that's it for singleton class team. That's it for singleton class. Now let's understand what is case class. So first one, case class is a class like another class. How we created classes using class keyword, object keyword. Case class is also a class. Okay, first one. Second important one, which can be created by using case keyword. Case keyword team. How we create a class by using class keyword. How we create a class by using object keyword. Similar way, we can create a case classes using case keyword. Okay. case keyword or modifier. Okay. Next one thing, it will reduce boilerplate code. We are liking boilerplate, but Scala is not liking boilerplate. Boilerplate means not our boiler thing. Boilerplate means repeated code. Boilerplate means repeated code. So instead of writing repeated code, for every class we write some important functions, some very, very important functions. So it will reduce or remove that boilerplate code, like 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 it will create boilerplate code. It will automatically create. It will automatically generates code like toString function. No need to write a thing. It will write. Next one, hash code function. Next one, and equals function. These functions implementation automatically adds in your code. Next, very, very important one. No need to use new keyword for object creation. No need to use new keyword for object creation. For case classes, Scala will create an object. Scala, no, not Scala. So it will create we can use direct statement to create an object. Okay. Now let's see, team, how can we create an object? How can we write case classes? First, let's take one example. So let me remove this statement. I am writing case class. I am writing class student case. So I am creating case class by using case keyword. Case class name student or employee. Then I am creating variables inside this one. empno int comma ename string comma stall int. That's it. So I created a case class. No need to write anything. Just toString functionality, hash code functionality, equals functionality already available inside case class. Okay. Next one. First I written this statement. Let me write this example 1. We return this example 1. Here I am writing one important note. Very, very important note. Very, very important to note. All parameters of case class by default is public. Okay, so every parameters we declare inside a case class parameters are public parameters. Okay, so what I'm doing, so let me write here client class. What I'm doing, employee, let me print ln employee. Okay, so let me create an object for case class. Val e1 equal to employee. Okay, so val e1 equal to employee, then I am passing 101 Srinivas, and next one I am passing salary. Okay, so here I am calling e1 dot employee number and println e1 dot employee number. Next one e1 dot ename. Next one thing, I am printing salary of e1 dot sal. Okay, right click on this program. Let's execute, run test. So we are able to create object, no need to use new operator. Okay, so next I am writing one more statement here. Let me print ln I'm printing e1. Okay, now let's execute this program, run test. Sorry team, let's use comment. Let's execute this one, run this program. So we got employee object, complete object we got. So remember one important point team, whenever we print a class reference, so this is reference variable of object employee, right? Whenever we print a reference, internally it is going to call toString function. Inside the toString function, it will print entire object. That's why we got output is employee of complete object information. So that's why I said, so no need to write a toString implementation whenever you are writing case class string. Whenever you are writing case class. Example 2, this is complete example. Let's start. In this session, we are going to discuss polymorphism. What is polymorphism? What is polymorphism? So poly means many things. Morphism means forms. Poly means many. Morphism means forms. Morphism means forms. So polymorphism means the ability to take more than one form. The ability to take more than one form. Ability to take more than one form. We can implement polymorphism in two ways. We can implement polymorphism in two ways too. Two ways. They are one, method overloading, and second approach is method overriding. So in two ways we can implement the polymorphism: method overloading and method overriding. So first let's understand method overriding. Method overloading, not overriding, overloading. What is method overloading? So method overloading means inside a class, inside same class, we can take multiple methods, means functions too. Multiple methods with the same name, but different arguments, at least order is different. So this is called method overloading. Inside the same class we can take multiple methods with the same name but different arguments is called method overloading. Let me take one sample example team. Say team, here I am taking one class called class arithmetic, bracket start, bracket end. Inside this one I am taking addition function team, def add. This addition function taking first function taking two parameters, a colon int comma b colon int. So first I am taking one function. So I am taking one function. Here it is taking two parameters. Okay. So here I am implementing print a plus b. So I am printing a plus b as a output thing. So I am taking another add function with the same name, but the number of arguments are different, c colon int. So I am performing addition of three numbers. So same method name, different arguments. So this is called method overloading thing. So we can create an object to arithmetic, ar equal to new arithmetic, and here I am calling ar dot add and I am passing two values. I am calling ar dot add. I am passing three parameters, 10, 20, 30. So depends upon the function we are calling, it will call corresponding function name. Okay, right click on this one. One more important point, team. So here test class is a child class. We can make it test class is a child class of app class. Then if your class is child class of app class, this main function is optional. No need to write main function. While runtime, Scala will add main function and it adds all these statements into main function. Okay, you can write object class. Inside object class you can define main function. That is one way. Another way is you can make your client class as a child class to app class. Okay, so now right click on this program, run test. So we can use println, so that output it displays in next line. Okay, right click on this program, run test. So 10 plus 20 is 30, 10 plus 20 plus 30 is 60. Yes or no? Let me take this program. So first approach is method overloading. So by using method overloading, we can implement polymorphism. Next important concept thing, method overriding. Method overriding. So method overriding means we can write same function name or method name inside child class. Inside child class is called method overriding. Method overriding thing. So method overriding is related to inheritance. So after completing inheritance, we will discuss method overriding. So now let's understand what is inheritance. So first one, what is inheritance? What is inheritance? Acquiring properties of one class into another class. Acquiring properties means variables. Properties means variables, and methods means functions. Acquiring properties and methods from one class to another class. One class to another class is called inheritance. Acquiring properties of one class into another class is called inheritance. So we have parent class and we have child class. So parent and child relationship thing. Simply we can say parent and child relationship. Parent and child relationship we call inheritance. The main advantage of inheritance is advantage of inheritance is reduce duplicate code or redundancy code, improves reusability, improves reusability. Example, I am writing class loan, class loan. In this loan class, we have 200 variables, and 100 methods, 100 methods. And I am writing class gold loan. In this gold loan class, above loan class, this class also need, this class above loan class, this class also above loan class, this class also need 200 variables plus above loan class, this class also needs 200 variables plus 100 methods same as above. First one same as above. Let me write it in this way. This class needs 200 variables plus 100 methods same as above loan class. Plus additionally it requires 100 variables plus 100 variables plus 50 functions for specific purpose, for gold loan purpose. Specific purpose means gold loan purpose. Similar way, I am writing one more class. I am writing one more class. So house loan class. This is also required same as above loan class. It requires 200 variables, 100 methods. Additionally, it requires 100 variables and 100 functions. And I am writing one more function, personal loan. This personal loan also requires 150 variables additionally and 150 functions additionally. Think team. So how many times we duplicated these 200 variables and 100 functions? Multiple times in multiple classes. Yes or no? Multiple times with multiple classes. So it increases duplicate code. We may think that copy variables and functions from loan class and paste it into personal loan class, home loan class, and gold loan class. But it increases program length, right? It is not in readable format. So to avoid that one, we use inheritance. First one, we can implement inheritance in Scala using extends keyword team. First one, we can implement inheritance using extends keyword. So same thing. Let's take these three classes. So what is our requirement is I want to create an inheritance. So gold loan class, I am making child class to loan class. Then remove this syntax. No need to write this 200 variables and 100 methods. And I'm making this home loan also child class to loan class. Then remove this all 200 variables and 100 methods. Then similar way, I am making personal loan class is also a child class of loan class. Then remove this duplicate code. So it will reduce lot of redundancy code thing. Redundancy code. So whenever you create a relation between parent and child, all parent class variables functions by default comes to child classes. So this process we are calling inheritance thing. Okay. So now let me take one sample example to understand inheritance. Here I am taking one class called class employee. So this employee class contain variable val, sal, salary colon int equal to some salary. Okay, and one variable thing. I'm writing one more class programmer extends employee class programmer extends employee. Then I'm writing val bonus colon int equal to some 5000. Okay, so here inside this class I'm writing objects val e1 equal to new employee. So here I'm calling I have in employee class I have def get salary. So inside this get salary I am returning salary. So here I'm using int return type unit. Sorry, instead of unit I am returning int. Okay, so similar way I am writing inside child class I am writing get sal and bonus. Okay, return salary plus bonus. So first one through parent class reference. First important point to you. Through parent class reference. Through parent class reference we can call only parent variables and parent functions. So parent variables and parent functions thing. So I am calling print print ln e1 dot salary. Next one e1 dot get salary. Okay, let's right click on this program, run test. So we got 20,000. So get salary, is it? Oh, we have to use println. It is returned value, we did not print. So first one I am printing println through parent class reference. Through parent class reference table. Okay, right click on this program, run test. So we got both parent class variables. Yes or no? Now through the child class reference. Through the child class reference. Through the child class reference, we can call both parent and child variables and functions. Okay, so I am taking C1 new programmer. So C1 dot salary, C1 dot get salary. Okay, similar way C1 dot bonus, C1 dot get salary and bonus. So this is child class reference here. Let me try. Let me run this program. So through the parent class reference, we can call only parent class variables, parent class functions. Through the child class reference, we can call both parent variables, parent functions, child variables, child functions. Through parent reference, if you try to call child class variables, println E1 dot bonus, we are getting red mark. It is impossible. A child can use parent money, child money, but a parent cannot use child money. Yes or no? Similar way, in object oriented program also, we have this approach. Okay, so understand right thing. So let's take this example. Yep, let's understand traits in Scala T. What are traits? These are like interfaces in Java. These are like interfaces in Java. Trait is a interface. Trait is a interface with partial implementation. A trait is an interface with partial implementation. A trait is a interface with partial implementation. It has both abstract and non-abstract features or non-abstract methods. Abstract and non-abstract method. So next one, what is abstract? What is abstract? Abstract means only declaration. Only declaration. There is no implementation. There is no implementation. There is no implementation. Only declaration thing. Abstract means only declaration. There is no implementation. Okay. In Scala, in Scala, in Scala, classes, comma, object classes, comma, object classes can extend traits. It means a class or object class can be a child class of trait. A class or object class can be a child class of trait. Okay, next one thing. Next one, in Scala, we cannot create, we cannot create, or instantiate, we cannot create or instantiate object. We cannot create or we cannot instantiate object to trait thing. Object to trait. We cannot create thing. Directly we cannot create. We can create object through child class only. Okay. So how can we define traits in Scala? Let's take example. Let me write some statement here. So here what I am doing, I am writing trait. How can we write a trait? We use trait keyword. Trait xyz. In this trait class, I am defining one function, def print function thing. Just I am defining a function. Okay. So here in child class, sorry, inside test class, what I am trying to do, I am trying to create an object. So first, let me take this important point. We cannot instantiate. We cannot instantiate. I am trying to instantiate val t1 equal to new trait. Sorry, new xyz. New xyz. See, we got an error. We got an error. If you place cursor here, it is clearly giving message. 1 minute. If you place cursor here, it is clearly giving trait xyz is abstract, cannot be instantiated. So it is giving error. So it is giving compile time error saying trait xyz is xyz is abstract, cannot be instantiated. Is abstract, cannot be instantiated. So we are getting this error. Yep. So understand, right? So for trait we cannot create, we cannot instantiate. We cannot instantiate. Second one thing. Then how can we create an object to trait? We can create a child class to trait. Class ABC extends xyz trait. First I am creating trait. Okay, so I'm trying to create an object. I'm trying to create an object to try it. So we are getting this error, right? So 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 we cannot we cannot we cannot directly create an object to trait. We cannot create direct object to trait. So we can create we can create a child class to we can create a child class to trait. We can create a child class to trait in this way. Let me take this example. Let me take example. Here I am creating child class to trait, but here I am getting red mark. Let's place cursor here. Here it is giving implement methods. Class ABC must be either declared as abstract or implement abstract method print inside ABC class. So first rule here we are going to get compile time error says make ABC class as abstract ABC class as abstract or provide implementation to print abstract method. So it is giving information ABC class. You can become a abstract class or you have to provide implementation to trait function that is called print. Otherwise this class will not compile. Okay, so inside this one we can write a def print and bracket start bracket end println. I am writing message saying inside ABC class. Okay, so we can create an object to child class team. Val A1 equal to new ABC. Then we can call A1 dot print function. Okay, so right click on this program, run test. So we got complete output. Let me take this entire program. Let's copy here. So I'm creating entire program here, team. So understand, right? What is trait and how can we create a child class to trait? How can we create an object to child class? Okay. Now let's continue traits. A class can be child class of any number of traits. A class can be child class of any number of traits. Let me take one more trait here. I'm writing one more trait. Trait display. Inside display, I defined show function. Okay, our ABC class is a child class of XYZ and display. That is a child class of XYZ with display. Now it is giving error saying ABC class should be must be either declared as abstract or it has to implement show function. Okay, I'm writing implementation to show. So here I'm writing show implementation. So inside ABC class print, inside ABC class show. Okay, so now I'm calling a1 dot print a1 dot show. Okay, so a class can be child class of any number of traits. First trait we use ABC extends to XYZ. Next traits we use with display, with so and so, with display 2, display 3, with display 4, with XYZ2. Like that you can add any number of traits as a parent to ABC class team. ABC class. Okay. So here what I'm writing, first trait we use extends, and next trait we use next trait we use with. First trait we use extends, next trait we use with. Okay, and next very important feature of traits is a trait may have implementation methods. That is the advantage of traits in Scala. So before Java 8, it is not possible. From Java 8 and Java 9, even in interface, we can provide implementation methods. Okay. So let me take one trait. Let me take a trait ABC. ABC class is a child class of XYZ. One function, def print abstract function. I'm writing implementation function, def show. Inside this show, I'm writing println inside trait show function. Okay. So I'm removing this show function. So this trait contain both abstract function and non-abstract function. A trait may have abstract function and may have non-abstract functions. Abstract means only function declaration. Non-abstract means implementation. So a trait may have both. Okay. So through child class reference, we are calling non-abstract method of trait, abstract non-abstract method of trait, non-abstract method of trait. For abstract method, we implemented inside ABC class. Okay. So now right click on this program, run test. So we got output. Okay. Let's take this program. Let's add here. So that's it for traits in Scala team. That's it for traits in Scala.